Hi everyone, happy Friday. Welcome on in. How are y'all doing today? Hello. Did y'all maybe see potentially the baby? Did y'all see the baby? Chat. Did y'all see little baby Lona? I may have on accident given away the results of the prediction. I may have given the results of the prediction. Like, guys, go follow Big Gamey. He says he sees a handsome scientist in his mirror. What a cutie patootie! He is. Hi, Dakum. Did you see the little one? Bring Alona back. Debs, she was hungry. Little one was hungry, and she wanted some food. She wanted some food. A handsome-looking scientist on Twitch. Andrew, are you streaming now? Chat, did Blink get haircutted? Some of y'all saw. Correct answer is, with 12,000 channel points in line, the correct answer is no. I did not get haircutted. Chat! Before we do anything and I start welcoming people in, we have to do something, okay? We have to do something very, very important. Cliff, hit it! Thank you, Cliff House, for McLean. Cliff, how are you doing today? Chat, first today was lovely and the breathtaking and extremely handsome gentleman by the name of Spikes! 24, hello, Spikes. We also have Risto in the house. We got Debs. We got Coffee Rocks. Becca, thank you for the resub. Becca, 9 months. That means we have a Twitch baby. Becca, what are we calling our Twitch baby, Becca? What are we calling the Twitch baby, Becca? We also have the lovely Peekaboo Draws in the house. How you doing, Peekaboo? NMD96, hello, Madame. Andrew Cece! How you doing, Andrew? Med, I hope you feel better soon, Med. I'm sorry about the head cold. That is no joke on that front. Lady Lara Croft, hello. Andrew, your meal sounds amazing. Bacon, pickles, tuna, Swiss cheese, and buffalo sauce. That sounds absolutely breathtaking. Lily, that's a great name for a baby. Crux, hi, Crux. Thank you for not saying sorry. Thank you, Crux. Travel the world, hello, Risto! Thank you for the 2 tier 1 gifts, says Risto. 2 birds are dead on and sea fiasco. Thank you so much, Risto Rock. Love your face, Risto. Bacon and tuna together was my idea. Debs, listen. Debs, have I told you that I had this... My sister had this little friend, and they did horseback riding together. And her grandmother or something was at the horseback riding place one time. And she goes... My granddaughter is a vegetarian except for bacon. And and the other old lady who was there was like, well, how could you ever give up bacon? Didn't really make much sense, but that's what was happening. The Marcy Ghost, hello. The Marcy Ghost, how you doing today? Gwendolyn P. How you doing, Gwendolyn P? Welcome on in, Gwendolyn P. Skip! Hi, Skip. Skip, who won today's trivia? Oh, God, it was me. Skip, that was actually not intentional. I have actually spaced on who won the trivia today. Skip is usually the trivia king, as it were. BitGamey, hello, BitGamey. How you doing, BitGamey, you handsome devil, you? Let me see. Dakum, hi, Dakum. Did you see the little baby, Dakum? Did you see the baby? Lady Lara Croft as well in here. Now, y'all, we do a couple of things here. I should go get some exercise. Go have some fun, Danny. Danny, thank you for the raid, my friend. Go have some fun. Also... Let's give a shout out to lovely Melissa in Denial. Danny will be on her stream on Sunday at 3 p.m. Eastern. It'll be the difference between an archaeologist and a paleontologist. They'll be talking about the differences between excavation work for particular resources, such as King Tut's treasures, versus the treasure of biology, such as the dinosaur bones. All that and more this weekend. Now, folks who are actually here, if you would like to participate, we always do this prediction at the start of every SciAnts News stream. And it's quite simple. It's how many topics will we actually finish tonight? I get really excited, and I love to talk about science. And I get a little overzealous. I like to imagine that we can do all the topics. So we have up to 10 topics that we have. And you could bet those channel points, and then you could use those channel points that you win to play games and play silly things. For example, if you like silly things such as video games, you too can make Sonic run across the screen. As a possibility. Make sure to get those votes in. Chat, where are we going to be beginning tonight? This paper hit me a little bit in the core, because I thought something like this already existed. And I was shocked to know that this was the first time such a thing had been described. So this paper is in the journal Nature. Surprise zero. So Charlie, listen. I could make zero an option, but I do make it a point to at least finish one topic each time. At least one is done. So even though it might be like, Blint, you're going on, and this is a 6-hour stream now, okay, it's fine. Also, Charlie, listen, we rabbit hole a lot here. We jump around like there's no tomorrow. The random rabbit holes that we go down tend not to count as full topics, because those aren't full SciAnts News stories. Instead, those are things of interest that we're chatting about that diverts our attention a little bit. And that's fine. We love rabbit holes here. If you ever have a question, I encourage you to ask it. If you're uncomfortable asking it, you can DM a mod, and a mod will ask on your behalf. And you can recognize the mods with those fancy pants swords next to their names. And we love, again, facilitating the questions here. We want y'all to feel comfortable and make sure that you are having fun and you're learning, and that we're providing a safe space to do that. That's one of our mission statements here. So, what exactly is this paper? Is that what sword means? Smikes, it means you're breathtaking, you're kind, you're very beautiful. And you do this. Indeed, Becca's breath. I did not know you could do that, Bit Gaming. That's very cool. Also, no, Debs. I know you're busy, Debs. Debs, you're breathtaking and wonderful, and I will never question that, Debs. Now then, chat. What we always do when we pull up one of these papers is we like to dissect the title. The title is a little bit crazy time in some instances. Very much a Harry Potter and the ... kind of study, where you don't really understand what the meaning of the study is until you actually dissect some of the science behind it. Murph, topic is almost too uncomfortable because I feel it's close to home. I learned the effects over the past half decade. Murph, it is uncomfortable for me as well. I had some heart issues at my last job due to stress, and it was because of the environment that we were in. It was very much the publisher perish. If you don't work hard and like outdo your lab mate, then you won't get the publication and your career will be destroyed, kind of thing. And so it very much like landed me on a medical leave because that's how bad it got. So it's an interesting study, but one that's actually gonna be, there is a positive note on this. There is a very, very cool and positive piece of science coming out of this study. Golganak, you are breathtaking, though. You're breathtaking, Golganak. I just wanted you to know. And hello, hi, Epical Sam. Maybe I missed it. So this article, Music Girl, is talking about mouse. This was a mouse study, and what's really, really cool about this is that they used a technique called optogenetics. Now, we're going to talk about what that means, but in a very, very easy, loosey-goosey, non-really close scientific term, it means that we shine a light on a cell and turn it on. So, for example, they're going to shine a light on heart tissue in a living animal and cause it to fire fast. So they're able to modulate the behavior on a physiological level in an organism using just light. And then what's really cool, so this is Murph, this is where I think it comes back to being cool. They can shine a light on a region of the brain to do the opposite. So you can make optogenetic constructs in either direction. You can make it so you shine a light on a piece of tissue to turn it off or turn it on. So they shine a light on the heart. It causes there to be a stress response of the body and the brain. If they shine a light on the brain to turn off a particular region of neurons, they fix everything. So this is the first connection mapped out of how stress can yield faster heart rates, which can then yield anxiety-like behavior in the brain, which can then be corrected. And you know exactly what neuronal clusters need to be turned off to get rid of those stress responses. So that, I feel like it's a first ever kind of study, and it's really, really exciting. And I'm very, like, I think it's going to be a really cool study to talk about. So there's a lot of science to take apart here. But we're going to have fun with it. The long history of heart disease interests me, but be careful about hospitals. I went to Mount Sinai for my heart, came out with my wife. Oh, Kennedy. Oh, Kennedy. Oh, Kennedy. Well done, Kennedy. Well done. How do I get brain light shining? So, Murph, actually, it's not yet present in humans. What you have to do is, in mice, you inject a viral construct into the brain. And the way they do it is, so the virus itself, it's just the coat of the virus. The actual viral DNA is removed. So you have no virus in this virus particle. And instead you replace it with new DNA. We can rule the galaxy. The lovely Moth Goth, aka Mothman's Cousin, aka Science Cousin, aka Mothman's Cousin, aka Theo. Thank you for the resub, Theo. How the heck are you doing for 1 year, Theo? What you do? How you doing, Theo? Thank you for that resub. Welcome the heck in, Theo. Great to have you here. Hi, Zulu. How you doing, Zulu? Zulu. How are you doing? What neurons do you need to turn off to lessen my anxiety? We will talk about that, Zulu. We will. Don't worry. It's gonna be. It's one that's going to be very difficult to first figure out to get integrated into humans, but we've made the first step. So, we had the question from Earth is how can you put optogenetic tools in your brain? So in a mouse brain, you inject a virus. That virus doesn't have viral DNA. Instead, it has this DNA that causes your cells to light up. Okay, the virus integrates that DNA into neurons or whatever cells they're injected to. Okay, when that happens, you can actually see that it's worked because you do the cells that have been infected turn from non-glowing to green, and then those green cells have your optogenetic DNA, meaning that you can now activate or turn them off with light. And so you know exactly which neurons have it because they glow green now, and you can get them into particular neurons through injection. If it doesn't have a viral DNA, how is it a virus? Okay, okie dokie. Artichoke spikes. Hold on. Bring this up. Hello, Danger Darren. Danger Darren, you've got a great name. Welcome the heck in, Danger Darren. Danger Darren, I feel like that's a scary name, but also a really cool name because you protect the world from danger. Protect the world from danger. So Smikes' question is a good question to ask because what he's asking is how the heck does this even work? So what we do is normally you have a virus-like compound and it's a shape of a virus. It's usually this hexagonal shape. So they're mapping out sections of the brain with their going to be psychotropic meds to counteract stress trigger. So Coffee, that is the dream experiment. So Coffee's asking if we can regulate certain regions of the brain and turn them off in a human or in a mouse. Could that be pulled into the actual like mammalian and human world? Probably because the great channel name, a quick read about it. Of course, Dan, thank you so very much. Appreciate you. You got a great name. Seriously. That is the dream, Coffee. Now, there are some drugs being developed on this front in particular for trauma. So, Coffee, there are some genes that folks have started to figure out that if you turn on or off, it will cause you to forget or trigger memory extinction genes. And the idea is if you can trigger those neurons or those genes when you're having an episodic flashback about a PTSD triggering event, you can get rid of it and erase it. Those also have to be very, very neuron focused. Ding dong, show worries, Theo! Theo, I know you said you were going to do some sewing this weekend, and I hope you have an amazing sewing this weekend. And pierogies. Please, Theo, I'd love to see the pierogies when you're done. I'd love to see the pierogies when you're done. Hi, Nelf. Welcome on in. Is this like quick detox therapy? So it has not been tested in human Smikes. It has been tested in mouse. And so in mouse, okay, we're We're changing it here. In mouse, what they end up doing is, and we'll talk about how these experiments work, but essentially you have a box that the mouse is in, and then half of the box has these vertical stripes, and the other half has horizontal stripes. And when the mouse, yes, Theo, Theo, the end game is to test in humans. That's the end game. But you have to make sure that it's working in a very clean way first in simpler organisms before you move it to humans. Just because, can you imagine if there's any kind of, a little Smikes, if there's any kind of screw up with your memories, right, Theo, the thing that I'm most terrified about is losing my memories. That I do not want to happen, Theo. So that's yeah, exactly. We're totally complicated. So that's a couple of things we have to do. By the way, Grimley, I love your face. I have not yet Epic of Sam. We will, but we're deep into a topic, so I don't want to do it right now, Epic of Sam. Advanced precise lobotomy. Close to it, Lobster. Close to it. Could do with one of my genes turned off that will never be developed in my lifetime. Med, I disagree. I think we're getting very close. There's been med studies in babies and infants that have had their genetic information removed. So there's been, like, they've been gene edited and all the cells in their body are actually changed to be reflective of that. It is highly unethical to do that, but it works successfully. And so if you can do it like in that situation, I think it's only a stone throw away from doing it in humans. The question is having to do it safely. That's the big issue, is can we do it in a safe manner versus this unregulated way that it was done previously. Exactly. And I have listened to Ali Ward's podcast, Ologies, and I very much enjoy her work. So what they do in this study for Coffee Rocks, the XYY syndrome, meds, is that I believe is called Superman, or is it Klinefelter's? I cannot remember the exact name of it. I think that's what it is. So what they do is they pick one side of the cage to put in an electric shock. And you have a mouse in here. So we're going to draw our mouse in pink because why the heck not? There's our little mouse friend in there. Now, that electric shock causes a mouse to do freezing behavior. Freezing behavior is how you identify fear in a mammalian model, right? So it's Klinefelter's, gotcha, meds. So that fear response will actually happen eventually independent of the electric shock. So what you're able to do, if you pair the electric shock with a stinky smell, that's our little smell cloud right here. The mouse will eventually learn that stinky smell means electric shock. And if you give it the stinky smell, it'll show freezing behavior even though you're not shocking it. And if it can also learn that the stripes mean electric shock, and it'll avoid that side of the cage. So you can train this animal to fear a stimulus, smell, visual, it could be auditory. You can set up the same experiment and you can play a sound and it'll also connect to it. It is Pavlovian, Smikes. It is. But that is defined as a classic learning and memory trait. It is classical learning and memory genes that we know if are mutated in animals or in humans, like Lady Clara Croft pointed out, can lead to dementia, can lead to Alzheimer's, can lead to forgetfulness, and all these different factors. So we also learn Pavlovianly. This is just a very strong example to look at. Hello, Millennia! Welcome in, Millennia. How are you doing today, Millennia? So, currently, and I need to double check if this paper is published, Murph, because I cannot remember if the paper itself is published, or if it's just a preprint or bioarchive, or if I saw it at a conference and it's not published at all. Which is why, Murph, I'm being a little bit careful in talking about what the compound is, because I want to make sure that I don't... the scientific equivalent of doxing someone's research. But I can tell you what gene that they're looking at. The gene is a histone modifying gene. It is an epigenetic regulator, so it modifies DNA structure and it's called ACSS2. And that's the gene in question. Now, this research group has been studying drugs that will also act on this particular gene, because they find if you turn off this gene in a particular region of the brain, then it'll actually, the mouse will very quickly forget this experience. But only this experience. So it was really cool. The researchers did a fair bit of experimentation where they exposed the mice to positive stimuli, and the mice still remembered the positive stimuli. So it was only pulling off these negative emotional connections and memories. The way they did that was they trained the mouse to be afraid of either the smell, the sound, or the lines. They then re-exposed the mouse to those stimuli, but gave them the drug. Those that were given the drug did not react. The ones that did get the drug, did not react. The ones that did not get the drug, or they got the placebo, which is like just the control experiment, they still reacted to the negative stimulus. Okay? Which I think is really, really cool. What's even cooler is both mice, when put into the positive stimulus chamber, still had their learning and memory intact. So it was acting on a selective memory, this drug was. Now, that is extremely complicated, Med, as you're pointing out, how that works. There's a lot of genetic experiments that have been done on this study. They did single cell sequencing to figure out, okay, what regions of the brain are particularly being affected? Is it where we're injecting the drug site? Is it going further away from the drug site? Is it only affecting the neurons? We think it is, because there's so many questions here that you have to make sure you get right before you put into humans. So and the mouse is infinitely more complicated than an insect brain, and the human brain is infinitely more complicated than the mouse brain. So it's a increasing complexity on that front. Yeah. See, Danger says, I hope any use of CRISPR-Cas9 will always be limited by genes that will only express in particular organisms' lifetime, meaning I really leery of messing with stuff passed along to future generations. So Danger Darren, what's crazy is the next generation, you can affect your next generation by your own experiences, independent of any genetic modification. Danger Darren, have you heard about that you can pass on genetic information that's been shown in mice via odor? And that's not even any genetic modification. That's just like fundamental bio here. Here, we'll pull it up. We'll watch a video on it. Makes sense. How are you doing today, by the way? How do you feel about 1 to 7% of human genome is uniquely human and 1 to 8% is viral? So Murph, we're very close in terms of our genetic sequence to other organisms that have nothing to do with us in terms of appearance, biology, or anything at all. And I think it's quite the differences are a lot of how that genetic information is regulated through epigenetic means. So it makes sense to me, and it doesn't end up scaring me. Wouldn't any information that's passed along those methods be orders of magnitude less impactful? Ooh, danger. Danger. We'll watch this mouse one. There have been human studies, not by active experimentation, but during World War II, there was the Dutch Hunger Winter, where the Nazis starved a whole village in Denmark. And women who were pregnant during that time gave birth to babies that had type 2 diabetes. And the reason, from an evolutionary perspective, is because having type 2 diabetes in times of need is actually beneficial for organisms, because it can help protect against that metabolic change that you have in times of starvation. Okay? What's even wilder is that those kids, when they grew up, had children that did not have any flavor of diabetes. So it can be very, very drastic, but it's plastic, meaning it responds to the environment. And these are huge environmental stimuli that can happen. So to me, getting type 2 diabetes as a function of what your parents ate is as intense as if you were to be genetically modified. To me, Danger. And I'm totally open to argument on that. But that's what I would put out there. And Kennedy says that the door to Pavlov's door or lab says, please knock, don't ring the bell. Kennedy, I love that. All made up, same stuff, just the way it's assembled. Exactly, Med, exactly. And the how it's assembled and how it's regulated. So how is it turned on and off? Exactly. Thank you for hitting that bell, Smikes. Then we have actually a counter. Chat, there is now a counter in that command that you can trigger to how many horrible dad jokes I say. No, Danger, I didn't mean argument like anything aggressive. I meant like that you can debate or discourse. Yes, I assume we are here to have a friendly scientific discussion and not be like, hey, there's no need to do that here. There's no need to do that. I don't yell in my private life, and I'm not going to yell in my public life. I know you know, Danger, but I just want to point out to any other party people. Chat, let's give an example of how mice can inherit sensitivity to smell. And Danger, this not only accompanies with genetic changes, but physiological changes where the brain neuroconnectivity changes as a function of parental exposure in the offspring. But the DNA sequence does not change. There is no mutation. There's none of that. All that's changing is how the genes are expressed, and it manifests as different behavior, different genetic regulation, different amounts of RNA and DNA being turned on, and different neuronal structures. Yes. Is that the same as that is an example of evolution, Epic of Sam. So getting bigger bills is not a single generational effect. That is over time, animals that have longer bills are more likely to get food, and so they are more likely to reproduce and pass on their genetic information. That is not transient. So the next generation, if all of a sudden having short bills is more beneficial, the next generation is not going to have short bills. So that's the difference between epigenetics and genetics. Is epigenetics is plastic. It can go away and come back. Versus evolution, it's continuous. Me too, Tommy Diplodocus. My bills have been huge lately. I tell you, those medical bills act on right up. So model organisms, Danger, are organisms that are used in the lab to model complex things that we can't study in humans, for example. So if you wanted to look at cancer, a model organism might be a mouse. You can study the effects of human cancer. You can actually transplant a human tumor into a mouse and see what happens. And that is an example of using a model organism, a mouse, to study a complex human biological question. Same thing with fruit flies. Fruit flies can be a model organism. They have 70% of their genome is the same as humans. You can mutate genes that have the same effect in fruit fly as it does in human. And you can figure out how does the biology work in something more simple than a human, i.e. a fruit fly, and then ask the follow-up question of how does it happen in a human. Guys, let's take a quick look onto the mouse, and then we'll move on to our first part about the heart today.
This program is brought to you by Emory University.
How can mice like these help us understand how one generation
Danger, not a problem at all. Please ask. That goes for everyone. If we say something that doesn't make any sense, I guarantee someone else may very well have that question. Or if they don't have that question, maybe you ask and we start explaining and they're like, wait a minute, that's not what I thought it was. I'm very glad that Danger asked the question. So please, anyone and everyone, ask questions. If you're uncomfortable asking, you can shoot one of the mods a whisper and they'll put the question to the chat anonymized. So it will not be linked to your name. We want you to be comfortable here, but that's not always the case. And so we want you to make sure to do whatever you need to do to be comfortable.
transfers behavioral traits to its descendants.
We of course can't use humans because it's just too complicated. We can't study multiple generations in humans, and we can't manipulate the process in humans to understand mechanism and causation. Mice provide the perfect model.
In fact, these mice have helped shed new light on the emerging field of epigenetics, which has profound implications on the way we might one day treat the effects of trauma.
It's been shown for over 100 years that we can take a mouse, expose them to a mild stressor, and pair that stressor with a sensory cue so that they will then avoid that sensory cue.
That's that Pavlovian learning that we just talked about. Speaking of just talking about, folks, make sure to follow our lovely friend Epic of Sam in his house. Go check out Sam. Go check out Sam. Love you, Sam.
Whether it's a smell or a sound or a visual cue. And there is evidence in humans in metabolic cases such as the Dutch hunger winter or the Swedish famine, where there's been profound starvation in a generation, that somehow has changed the metabolic processes in subsequent generations. And that seems to be an epigenetic mechanism. And we were really interested in whether such processes may be going on in our model systems.
So this lab uses mice spikes for primates and are actually getting phased out more and more. They're still usually in drug studies are involved, but a lot of the fundamental biology that was utilized to ask in chimps is now starting to go away due to ethical reasons. There is still a center at Emory with primates called the Yerkes Center. It's located in the CDC, which is actually right next to the building that I worked in. But again, that is limited to more drug studies, and they're very cognizant and aware of the chimps' care and their living situation. Why is it ethical to do on mice? It's considered a complexity question, Smike. So, what all does it take to have a mouse happy in times of non-experimentation, for example? How easy is it to make the housing for them? How easy is it to keep them enriched and having a high quality of life? And it's much easier to do that with a mouse than a chimp. Now, we can start arguing semantics on that front of well, how do we really know beyond on the molecular level that they're actually stressed or not? But that's essentially what it comes down to. Sensory triggered, do you help myself with stress, and I've trained myself. Matt, it's not easy, but the training is important. You're never bad, Smikes. I'm considering nerfing that comment, sir. Everything's involved with animal testing to do put the animal's comfort and quality life on the list of must-have for experimentation. In some countries, McZenith. In some other countries, not so much. Hi, Darren. Welcome in, you lovely and breathtaking, amazing soul, you. Welcome in, Darren. We're talking about epigenetics for the moment, and then there's a really cool new study on heart biology that we're going to get into.
Now, Emory researchers Carrie Ressler and Brian Dias have shown that an experience linked with a smell can modify the architecture of the nervous systems in later generations. They have published their findings in Nature Neuroscience.
What we found in the study was that conditioning animals or training them to associate a particular smell with this mild foot shock gives us descendant generations that are slightly more sensitive to this smell.
So what's cool is this is the olfactory center in a mouse's brain. It's near the nose. And what they find is if you expose the parents to a certain smell plus the electric shock, the next generation, so the babies, if you take a look at the olfactory center of their brains, the region that detects that particular odor is enlarged like this and has many, many more neural connections. That is absolutely wild to me. And what's even crazier is the next generation, if you don't give these mice further exposure, the next generation shrinks back down. Again, it's not a function of genetic mutation. It's a function of how the genes are being turned on and off. And the only thing that you learned can be
And their brain devotes more real estate to processing the smell.
And this is about 50 microns.
To our minds, we needed to figure out how this was actually occurring. And there are two real possibilities. One is biological transmission, which is very similar to cultural transmission and you learning from your parents or your grandparents as to how things are done. And the other possibility was an inheritance of these particular traits.
So they separated.
I don't know him, Smikes. I knew the first researcher who was chatting. He taught one of our classes. I don't mean the whole course. I mean he was a guest lecturer in one. Layman terms, gene member. Yes, Med. So it's yeah, the difference between learned memory versus genetic memory. Exactly.
Mice pups from their biological parents and allowed for them to be raised by unrelated mice.
So he gave them surrogate parents who've never been exposed. And then the question is, if it is trained independent, then these animals shouldn't remember. If it's trained differently, then they should. If it's genetic memory, then they should remember.
It had not been conditioned to avoid a certain smell.
What we found, shockingly, is that the neuroanatomical changes still persisted. That is, the brain still devoted more real estate to processing that cue that was salient to the ancestral generation.
This study adds to a mounting body of evidence that lifestyle choices and trauma can have profound repercussions beyond one's own life. And one day we might be able to use this knowledge to the advantage of both mice and men.
If we take the adult and train them to no longer be afraid, will it prevent that process from transmitting to the next generation? That might have very important implications for treating at-risk populations.
The preceding program is copyrighted by Emory University.
So again, huge amount of data in there and a huge amount of implication. And it's also kind of scary, right? Like first of all, I have to have a disclaimer. We don't know how much of this is happening in humans. There just hasn't been enough experimentation to figure that out. But we have shown it happens in mouse, in worm, in fly, in fish. And the whole idea is if these genes and behaviors are conserved across different organisms, you probably bet on the fact it may happen in humans as well. Right? So that's something just to keep in mind when doing these experiments. So I hope that danger, that was a fun rabbit hole, and that answered your question. Let's get back to our original paper for the night, folks. Study number 1. The cardiogenic control of affective behavioral state. So this is what we talked about. Let's see, if they weren't treated ethically, it might cause a variable. Yes, Coffee. But Coffee, here's the question. The definition of how to treat ethically varies depending on the organism, and also depends on where they're being kept as well. So it's wild to me. Coffee, let me tell you something. This is absolutely crazy time to me. Hi, Hugh. Welcome in, Hugh. You're so handsome, Hugh. Hugh, is that Brendan Fraser? It is Brendan Fraser. Thank you, Hugh. I love that, Hugh. Thank you, Hugh. That's a very lovely message, Hugh. That's a lovely sentiment, and I appreciate it. Welcome in, Hugh. So, Coffee, in mouse papers. Actually, this one's a mouse paper as well. Let's go to the methods. Where are the methods section? Okay. So the joys of being a nature paper, Coffee, is that the methods section are usually hidden away. In the supplementary information, let's see. I'll do a quick Control F. Okay. So, this right here, Coffee. The mouse were given food and water. Hi, Alex Vixen! How you doing, Alex? How you doing, Alex? Try to go sleep. Have a good rest, Med. Have a good rest, Med. Coffee. This saying that they got food and water is actually quite a large variable. Because the food, even though the diet might be standardized in terms of mouse pellets, has actually shown to be different depending on what institute the experiments are being done. So, there's studies, Coffee, that look at the gut microbiome, looking at how the gut is assembled and what are the bacteria in the gut that give you, and the microbiome that gut and that talk to the brain and the other parts of the organism, all influenced by diet. It turns out, if you do your experiments after you order the mice and they get to your lab pretty quickly, they will have a different result than if you grow them up in your lab for a few months and then do the experiment. And that's all because of their gut microbiome and how the microbiome is organized. And it's, again, influenced via diet. And then it gets even wilder, Coffee Rocks. Because if you do the same procedure but at a different institution, you might get a different answer because there are different dietary components that are just a function of like what's in the water and what's in the food at a different university. And this isn't limited to mice. Coffee, what drives me up the wall, and this is just a byproduct of today's publication atmosphere, is if you, in your paper, fruit flies, for example, I always insisted on putting the recipe of the food that we gave them and how the food was made. That was always taken out because we're so limited on space. So the fruit flies, it was said they got standard cornmeal media. So coffee, that doesn't have the brand information of the yeast that we ordered, the yeast extract, the cornmeal, the molasses, the antifungal that went in there, the concentrations of these things. And so all of a sudden, if diet is influencing any of these behaviors, it's very difficult to then replicate the study because it's not there, right? Because it's just going to be variable and you don't know the exact recipe. And it's very, very frustrating to me. I don't know that in vivo is always representative of in vitro. And vice versa, Murph, right? So what you just look in and see in a dish is not necessarily the same in an animal, and vice versa as well. By the way, for a second, I heard singing. I legit thought Blint was an ad. I'm so sorry, McZenith. I'm so sorry. I am so sorry, McZenith. McZenith, here, I'll give you some singing. Hold on. This is only because I care about you.
Blint the science guy.
The science guy.
Blint the science guy.
SciAnts rules.
Blint the science guy.
SciAnts is a partner on Twitch. With lovely wife Lita.
Blint the science guy.
That's only because I care about you, McZenith. That's the only reason why. Hi, Tactics! Welcome in, you handsome devil. And hello, Kai. Welcome on in as well. So yeah, coffee. Diet influencing a huge amount of things. And again, it's not even written out in the methods because you're so limited on space that even the editor will start cutting stuff and be like, you don't need to put all this detail. And for me, granted, my papers were obscene lengths, but it's definitely something where I thought it was important data to have in there, right? Okay, so really quickly, let's talk about the study and some of the things that they did in there. So the first component that we have to establish is they did a series of experiments called optogenetics. Let's actually get into what the heck optogenetics are, folks, because I feel like that's something that we really need to get to. So let's get to some light. The title of this video is quite accurate for optogenetics. It is the process of light controlling your brain.
Imagine being able to remote control your cat. By clicking a remote at a receiver on your beloved kitty's head, you could make it walk, turn in circles, or even stop moving altogether. Maybe with the press of a button, you could even put it to sleep or turn off its sense of pain when it hurt itself. And even weirder, what if you could control your own body that way? Well, there's a scientific technique that might someday deliver just that. It's called optogenetics, and it's a method for controlling the function of cells using light. Even though it sounds a lot like mind control, optogenetics is really most useful for learning what specific cells do or for treating certain conditions.
And what's wild is this has been shown to work both in a dish and on whole animals. So in our mouse example that we're going to be looking at, you have to drill a hole into the mouse's brain, like skull, and get a visible location of the brain where it's going to shine light on. So the light cannot go through the skeleton. Okay? But I was actually lucky enough to run this experiment in a fruit fly. And in the fruit fly, hi, Michael Hasser!
Say what?
In the fruit fly, You can have these animals free running in a dish. You can have these animals free running in a dish and shine the light on them, and they will have a response. Like, you can turn their neurons on and off. So it's the only, like them and zebrafish, you can, because they're transparent, you can shine the light and trigger that behavior. Where can you get this shirt? This is Looking Cool Zedman shirts, Mike. Where is Looking Cool Zedman shirts from? It's a great question, Mike. That's our friend Looking Cool Zedman. Make sure to drop him a Fancy Pants follow, and here is his merch store as well. I got you, Smikes. I got you. Oh, you did. The duck one. That is very fair, good sir. I think that is their sponsor. As a fan of dystopia, can it be used for... Oh, listen, Murph, my friend. Unfortunately, many things in science can be used for ill. You can very quickly imagine a dystopian world where you shine a light on someone's brain and it activates an army. Right? That is a very far way away from happening in this world. Right? Because again, we can't actually get through the exoskeleton and skull of a human to be able to be doing these kinds of behaviors and like these kinds of analyses. But it 100%. Murph, the same thing with genetic engineering, like CRISPR, right? You can imagine if I did genetic engineering, I can genetic engineer some kind of unique behavioral feature that I'm looking for, and that can create a dystopia, or where only the rich can have genetic modification. There's this whole gap that emerges between populations, and then it spirals and it causes the destruction of the existing civilization. So we can, Murph, 100% take this to all extremes. Actually, Murph, we did a Gattaca watch party on Discord, and then we talked about the science behind it not too long ago. Was it maybe... Actually, it may have been a while ago. It may have been like 8 months ago, something like that had happened. But yeah, yes, we talked about the science behind it. So Murph, 100% that could happen. Any one of these can be used for bad. When I'm talking about the science and presenting it, my hope is that it's not going to be used in any kind of bad way. Instead, I'm presenting it as it's the beauty of science, and that maybe, I'm trusting in us as a community, like this Twitch circle right here, to admit that what is the beauty of some of these things and why we want to have good things happen and use these things for good and not for bad. But Murphy, you're 100% right. There are things to be aware of that are maybe possibly potentially a little bit scary on that front. Did you know that Alexa Vega's musical is about that exact... Wait, hold on. Andrew, Alexa Vega, the superstar from the movie Spy Kids and Spy Kids 2, Electra Boogaloo, her singing, Andrew, I learned from you that she actually had a singing career. Because I remember as a kid, I got the CD for Spy Kids 2 because I really liked her voice and I thought she was a good singer. I didn't know. I will have to look into that. I wonder, that might be well, Andrew, you can tell me. It might be a fun thing for us to dissect the science of that musical. I do not know the plot of it, and I have not seen it. But I wonder, again, if that's something that would be fun to, like, one night watch it on Discord with folks, and then the next stream dissect the science behind it. That's really cool. Thank you, Andrew. I did not know that. She was also Shiloh and Repo, the genetic opera. A genetic opera. Now she's in Hallmark movies. Listen, McZenith, don't judge me. I love Hallmark movies because they're predictable, they're stupid, and I don't have to be afraid. It's blunt nerves acting on that. It's like it's the same with the really bad Netflix holiday movies, right? Where it's the same thing every single time, but it's not stressful. You know it's gonna end happily. maybe there's a modern day twist to something. But in the end, it's probably going to be fine. Sometimes I'm pleasantly surprised. I'm like, oh, she doesn't end up with the dude. She actually just makes up with her family and it moves on. Right? Like, that's always like a surprising one, but, you know, something to... It's a rock opera. Ooh, wait, it's not a rock opera. Okay, well, it's still interesting. Could be interesting. Possibly, maybe, potentially, sometimes. Watched that movie last Halloween at House a musical horror night. Is it scary, Zulu? Is it it's scary, my friend? Guys, by the way. Melissa, thank you for the lurk. Guys, go check out Little Arrow Soaps. We've had Little Arrow Soaps on here on the stream to talk about the science behind soap, and they're absolutely breathtaking. Go drop them a follow. And Zulu's the other half of Little Arrow Soap. Zulu, love your face. It's a bit out there for certain. We'll have to. I'll have to check it out, Kennedy. But Murph, the whole point is, yes, these are 100% could be in theory used for something terrifying, but that's why luckily we have ethics review boards. Again, that doesn't prevent countries from going off on their women doing whatever they want, nor does it prevent individuals or groups of individuals from doing what they want, but you would hope that we have enough ethical sense to not endorse that happening. And yet, faith in progress for good and not for moving backwards is at least the hope. Yes and no, it depends on whether you see cheesy love letter to a body horror or social commentary. Okay. I'll still have to check it out. Didn't think it was scary, but I can see how some people might think it's scary. But to me, I found hard to be scared in a movie where everyone is singing all the time. Zulu, I will say I did get a little bit scared from the Rocky Horror show. That was a little bit scary there. It's a little bit scary. Anthony Stewart Head and Sarah Bryan were both brilliant in it, and so was shockingly Paris Hilton. Huh. I actually don't know who Anthony Stewart Head or Sarah Bryan is, but I do know Paris Hilton. Watch children's shows for the same reason, comforting and not scary. Golganak, that's why SpongeBob is amazing. Played Magenta in RHPS. What is RHPS, Alex? Rocky Horror. I mean, look, actually, Zulu, it's. There's nothing wrong with Rocky Horror. It's just I had no idea what to expect. And it was not what I expected. And so I was just sitting there with Lita, and I was just like this the whole time. Oh, that gotcha. Thank you, Smikes. For some reason, Smikes, this is how, and Alex, this is how well I remember it. I don't know the names of anyone. I don't know the names of anyone in that movie anymore. I've forgotten it. I've watched it once with Lita, and then we saw it once in person at a theater, and I've forgotten most of it. And I'm okay with that. I'm okay with that. Hi, Maddie Holmes. Maddie Holmes, don't know about that, but I do know Anthony Stewart Head owns West Ham United and Ted Lasso. Thank you for that big gaming. Played Christina in Phantom of the Opera. Grimly, had to stop watching it. I could not finish Phantom of the Opera. Tim Curry is breathtaking. Look, Zulu, Tim Curry in Muppet Treasure Island was gold. The musical on Broadway. I have gone to 2 musicals on Broadway at Grimley. They were the exact same musical. Both of times that Lita wanted to go see it. That is my exposure, unfortunately, to Broadway musicals. Haven't had a lot of ones that like we maybe wanted to go see, didn't. Frankfurter's Maid. For some reason, I do remember the name Frankfurter, Alex. But again, that's like the movie. It's like I see a couple of images, but nothing really else. Where he didn't steal it. Man's a treasure. The man's an absolute treasure. Eris is the best interpretation of Treasure Island ever. Second, maybe the Treasure Planet. Look, Zulu, Treasure Planet was beautiful. The animation in that movie, so well done. I am sad that all these other movies are getting remakes. That and Atlantis. Those two need live action remakes. If they act like, right, we're getting a live action remake of Moana coming soon. I'm like, guys, go do Treasure Planet and Atlantis. Those would be beautiful to make live action and bring back some of those feelings of it. And they're so good. Oh, and yes, Maddie, the Wild Thornberries. He was the father. Lance was basically sorry, but it was still fun, Maddie. It was still very fun. Titan AE. So hilarious enough, Zulu. When Titan AE came out, my dad was like, "We can't go see this. This is a scary movie." And then I was like, "Dad, it's a cartoon." And then we went to go see it, and it was very beautiful. I do not remember much about the plot beyond like they're escaping Earth. Is that a Disney property or by someone else? I can't remember, but that might be also a fun one to have as well. The new Peter Pan. Is it any good, Big Gaming? I think we're gonna watch a movie on Apple TV Plus tomorrow. It's like a rom-com on Apple Plus, but I don't know. DreamWorks. Okay, gotcha. We should dress up as Wild Thornberries, maybe, Maddie. Atlantis was it was. Treasure Planet became one of Disney's worst failures. Oh, financially, right, Alex? Not critically. Because I don't know, I really enjoyed the movie. Halfway through, Mrs. Gamey was asleep. Listen, Big Gamey. Mrs. Gamey works extremely hard, and she was doing all the fancy pants things, today. So I'm not surprised, Big Game. I'm not surprised. I hated Hook. I'm gonna level with you, Big Game. I did not enjoy Hook. I did not like. Who was it? It's the actor who was in Rain Man. That actor, I forget, but he was in Hook. Dustin, I did not enjoy Dustin Hoffman's performance in Hook. It took me out of it. I did not think he was a good Hook, and that's what kind of nerfed it for me. I'm used to the good pirates, like we talked about Tim Curry, and a bunch of other flavors on that one. Pinball Table used to play in England, found it in Austin. Big Gamey, not a knock on the games. One of my favorite pirate movies, Big Gamey, was a complete box office disaster, and it was it actually put the movie company Carolco out of business, and now it had I'm forgetting the name. Alex probably knows who this is, but it had a female lead who was named Morgan, and she was searching for this pirate treasure, and she was like it was like this massive production in the 90s pirate movie, and it did so poorly it put the whole company under. I think it may have been Jenna Davis, Grimly. That sounds right. I don't remember the title of the movie, but thank you, Sam Floric. But it was it was probably it's probably overhyped now if I tell y'all how great it was, but I thought it was a really fun movie. About pirates. Cutthroat Island! Yes, Big Gaming Maddie. Y'all got it. And Alex. Thank you, Alex. We got our first DVD player. The longest time we had only 3 movies. Titan AE, Toy Story 2, Mission to Mars. As far as boring to me as a child, I watched... Yeah, I 100% agree, Zulu. 100% agree on those. Chitty Chitty Bang Bang used to scare the pudding out of me as a children's movie. I have not seen it, Coffee. For that reason alone. Because I was... It made me nervous as well. Pirates was considered box office poison before Pirates of the Caribbean. Except was it Muppet Treasure Island, or was that a straight to DVD movie? Liked it, but didn't care for where the map was printed. Wasn't it on a scalp, Grimly? Am I remembering that correctly? Oh, based on... Oh, really? Gotcha, Maddie. Okay, cool, Grimly. See, it's remembering. Grimly, there is a rumor, though, that they're going to do another Pirates of the Caribbean with Johnny Depp now. Muppets didn't really count. Are you sure, Matty Holmes? I know, Smikes. We were so hardcore rabbit holing. Smikes, this started with the shirt. Because you wanted this bird shirt. It's like half penguin, half droid. It's a whole thing. It's a whole thing. I love you, Smikes. Okay. Speaking of pirates...
You don't understand. You don't understand. If you understood, you wouldn't understand.
It's a great point in this stream to remind you that I have a favorite pirate game coming up made by my favorite pirate, Irish John Game Center. If you're not checking out legendary Irish John Games, please drop that follow. And if you drop in that follow, then please wishlist the video game Rise of Piracy. Right now, folks, wishlist that helps support our friend Irish John, one of our besties.
Ahoy there, feckin' scientists.
The best pirates out there, folks. Go follow the legendary, the breathtaking, the handsome Irish John Games. Big Gamey, thank you for that. Big Gamey knows my brain very, very well. He's like, oh, well, this is the perfect plug for Jern. Yeah, sure. Okay, let's get back to optogenetics of how we can regulate cells to turn on and off using light and how this is going to connect to anxiety.
It does this by using light to control certain pathways on a cell's surface called ion channel receptors. These are sort of like switches that start and stop electrical signals traveling down your cells. Normally they're activated when molecules like neurotransmitters attach themselves to the receptor. That causes charged atoms or ions to move into the cell, which generates an electrical current that can make other cells stop or start firing. These channels are ultimately what makes your body move and function.
And so you're activating it using light. Hi, Dame Karen. Welcome in, Dame Karen. How you doing, madame? Dame, welcome on in.
Optogenetics works by using light to control this process instead of molecules like neurotransmitters. Using fiber optic wires, scientists can transmit precise light pulses that last just 1/1000th of a second directly to a small group of cells, and that triggers ion channels to open and start sending signals. Now, even before this method, researchers have been trying to control ion channels for years, since that could help us figure out how cells work or even treat some diseases. But other methods like drugs or electrodes tend to be too slow or imprecise. To really study a small number of neurons, researchers needed fast, accurate signals, and that's where optogenetics shined a light on the problem. Literally. It all works thanks to special proteins called opsins, which are naturally found in organisms like microbes or green algae. When
a piece of information to highlight. These opsins that are discovered, what's really cool about them is that they would not have been discovered if it were not for basic biological research and funding. So people did not look for opsins in order to use them in these neuronal experiments where we turn neurons on and off. Like, that was not the goal when folks discovered opsins. They just happened to be looking at it. It happened to have come together really nicely on that front. So it's just, again, something to keep in mind, that not all of these really cool pieces of fundamental biology are a feature and demonstration of what you would find in, like, that people were just actually looking for left, right, and center. I hope that makes sense.
When they're exposed to certain particles of light, they'll generate an electrical signal and open a cell's ion channels. We've actually known this about opsins since the 1970s, when researchers noticed that one in certain bacteria, called bacteriorhodopsin, opened its ion channels in response to green light. And today we know about plenty of others, which start and stop firing neurons in response to all kinds of light.
So what's cool is, Coffee Rocks, is that you can put in multiple opsins into a cell. So you can have, Coffee, a cell or a neuron that will fire if you shine green light on it, and will stop firing if you shine red light on it. Or you can get even more clever with your combinations. You can have different populations of neurons that fire with different light sources that are turned on and off. And those collectively, like, that kind of brings you back to what Murph was talking about. In theory, you can control an organism. So when I did this, Coffee, we did it one step back in terms of time, scientific time. What I originally used was we used heat. So heat can yield and turn on and off neurons if you, like, put in the right construct. And that was what I was using, and I thought was really, really cool. What is scientific time? What does that mean, NMD? Oh, sorry, NMD. Like, it had not been either invented at the time or not been that heavily used or not available at a cheap price. Those are some of the components there, if that makes sense. Zulu says, I love that I'm watching one of my favorite streamers watching one of my favorite YouTube channels with the speaker wearing a shirt referencing another one of my favorite YouTube channels. And Zulu, I am also wearing a shirt representing one of my favorite streamer buddies. So actually, and Zulu, I'm wearing a sweater that represents one of my most favorite musical stream on Twitch. The one, the only legendary Thug Shells, who's our friend moderator Andrew CZ got me this sweater, and it's filled with so much love that I constantly have to wash it because I may have some baby spit up on it. So, there, Zulu, are so many obscene levels of nerdception here. And I hope that you find it as Gucci as I do. And I know, there are Easter eggs everywhere. Easter eggs, you know, pew! Pew! Like, now I just need, I don't know, a hat. I need, like, oh, actually, Zulu, I can do you one. I got a BitGamey coaster here that I use all the time. It has a special message on the back. So my BitGamey coaster that I'm using, I have my Irish John. I don't have my Irish John mug in here, but I usually do. It's in the washing machine or in the dishwasher. I got my Mr. Jimmy B 93 stickers. I have Wristrock stickers. I even have a pin from the lovely BitGamey looking at me. I've got all this stuff. There's all kinds of fancy Easter eggs lying around here. There is a statue from Moko Made here next to me. I can't show you all that one, but there is a little dinosaur statue next to me from the lovely Derek Devon. There's all kinds of fancy things here. All kinds of fancy things. I'm sorry, NMD. Chat, let's continue Optogenetics.
Who let the
But no matter how many options...
Let's go!
Exactly, BitGamey. Now we gotta give them a shout out, BitGamey. Lovely Derek Devon and Moko. Carlo! Stream scribe. Hold on, sir. I do have stuff from you here as well. I'm just throwing it out there, Carlo. Just throwing it out there. Made with love. I know there's so much in the tiny office, Mikes. I know. Shameless promo. Is it shameless though, Carlo? Chat, if you're not checking out Carlo, aka the stream scribe, go drop him a follow, folks. He's our Monday Fun Day partner. He streams Monday, Tuesday, Wednesday, Thursday, Friday. Breathtaking, amazing soul, extremely handsome, extremely kind, and we love Carlo, the stream scribe here. Guys, go check out Carlo, the stream scribe. Sir, I hope you're having a great evening. I hope you got some nuggies today. I had a gigantic hankering for nuggies, but could not get out of the house today. I was dealing with a bunch of grant stuff and conference planning, and it was maddening today. And I was hoping to take a little one on the walk, but the past 3 days it's been raining, and we couldn't go on our walk. We couldn't walk into town. We couldn't do all our things. So it's been a whole thing, Carlo. But I've been really wanting like a nice serving of meat, as it were, Carlo. I'm like, maybe tomorrow, possibly, potentially. I don't know. Chat, let's continue on Optogenetics and make sure to follow Carlo, the stream scribe, aka Carlo, because he is on the partner push. Love you, Carlo.
we found, it took until the beginning of the 21st century for scientists to really understand the applications of them. They really
look around here. I only see Anchor's hardware crest, but some science stickers and arrows. PC will change soon. Got a little while at the partner party. All the good things, Zulu. I do have Anchored. One of Anchored's pieces is hanging on the wall here. You can't see it. It's out of the frame, but Anchored's wood burning is there. I've got a bunch of other art from our partner party that's located over there that I need to clean out some of these shelves and build a shelf downstairs so I can move some of the books down so we have room for the art pieces. Zulu, this has become like almost the stream room shrine, and having eventually it'll just be the dream room, right? The dream room being that it's only for the dream and not for like work stuff as well. But Zulu, not there. Maybe eventually one day, potentially Zulu, we will be there. But you never know. You never know. We can always dream. Guys, go check out Derek Devon and Moko Made. All right, let's continue.
realized that if they could somehow get these opsins into animal cells, they'd be able to control the ion channels in the fast, accurate way they needed. And in 2005, they did it for the first time. In the journal Nature Neuroscience, researchers announced that they'd introduced opsins into a rat's brain cell, although the cell was in a petri dish and not a live animal. When they shone blue light on it, it showed a spike in electrical activity. Essentially, they had made a light-sensitive brain cell. But trying this on live mammals was a lot harder, because smuggling opsins into a living cell is tricky business. To do it, researchers had to develop a special virus that could transfer the protein onto the surface of an animal's cells without the virus itself running haywire. Then if that worked, they could just insert a wire into the animal's brain and use an LED or laser to start manipulating neurons.
And that's actually what they ended up doing with this study. They looked at both brain and heart to shine the light on. So they want it to be, and you could do both directions. You can activate neurons, or you can turn them off using this kind of methodology. And for this study that we're talking about today, they're looking at the connection between anxiety and stress on the heart and the brain. And it turns out some anxiety originates from the heart and then talks to the brain, and if you turn off certain neurons in the brain, it feedbacks and slows the heart back down. It also makes sense from a biological perspective that this happens. For example, the fight or fight response, right? That fear response where the animal runs away in fear, it's a immediate reaction. Thought anxiety was primarily cortisol related. So some types of anxiety, yes, but the question here, Smikes, was like different types of anxiety that exist and where they originate from. So there had been this whole idea, let me get you the actual quote in the past. Okay, so the idea of your heart racing because you're afraid or stressed out. And that was the original desire to check this phenomena. I'm trying to find if there's a quote here that they had. Because they utilized high-risk context, and a racing heart goes to your head and increases anxiety. They didn't look at molecules in terms of cortisol in the brain, but they were just looking at more the neurological science side of things. Stress creates cortisol. This is grim. I'm sorry if I missed it. What fiber did they use? So Murph, they use an LED fiber optic cable, like light source, to be able to do it. For the actual model of what fiber, I can throw the paper is open access. I don't know if they'll have it in their methodologies. Let me do a quick search. Molecular cloning, cardiomyocyte, viral delivery, in vitro characterization, blood pressure, wearable pacemaker, freely moving behavior with pacemaker, EMT, OFT, operant learning, labeling, analysis, in situ histology, optogenetic experiments. There's the virus, and where it was through EPHIS. It just says a probe. Hi, Princess Sparkletude! How you doing, Princess Sparkletude? Welcome on in, Princess Sparkletude. We have been smited. What do you mean, Smikes? What happened? Hi, Kids Creations. Welcome on in, Kids Creations. How are you and your awesome wife? Ah, there's the awesome wife! Ah! Chat, check out the lovely, amazing Kids Creations. Streamer extraordinaire. And there's their awesome wife as well. Oh, I'm smiting you. Oh, I see. That's, you know what? It's probably worthwhile. You mentioned peaches. Ah! Love you! Peaches. Okay. Murph. That is the quote of what kind of optogenetic light that they were using. So right here is in the paper, it says optogenetic freely moving behavior. And this is the laser that they used, and it delivered a constant light measured, and it does not tell us what kind of wire and how it works. Quiet, you! No, Alex! No! Alex, I don't think you saw this, Alex. Let me show you, Alex. Alex, I'm gonna give you a high five.
My best friend.
Alex, how do you feel about that? How do you feel about that? As Cal's Bells! Hi, Kels. You are breathtaking. I love the socks that you made. Chat, Kel's Bells, part of the Mokaluku big partner party, and they made an amazing series of socks today. Kels, you are amazing. You are breathtaking. You're an absolute legend, and I love your face. I was very much enjoying the vibe this morning of the stream, just hanging out. I was getting work done, and it was just like, it was a nice, safe, positive feel. Guys, go check out the lovely and amazing Girls Bells. Give me one moment, folks, to give that Fans Bands Pinky out shout out. In 3, maybe 5, 4, 3, 2, maybe 1. There we go. There's a shout out. Kels Bells. Love you, Kels. Love you guys. Guys, go listen to Kels Bells. But yes, Alex, if you now type !BFF.
My best friend.
Would they be able to trigger the light remotely? Coffee, do you mean the researchers or the mice? Because actually, Coffee, there are two answers there. So you as the researcher are able to trigger the light. Like, you don't have to be in the room. You can, the light is being controlled by a computer, and the computer is usually in a different room, because what you don't want, so this is crazy, Coffee. In terms of learning and memory, mice and rats can learn your presence and your smell and your location in the room, and they can use that as a metric of what they're learning, which is kind of wild, right? So you want to be off site, so you can be in a different room, or you can be behind a barrier controlling it via a computer. What's also wild, Coffee Rocks, is they've done the optogenetic experiments where they actually identified the region of the brain that's responsible for addiction and addiction-like behavior. So it's like, you know, serotonin and dopamine release. And they've actually done the kind of experiment where they found the region of the brain that's activated when a mouse is doing drugs. And they gave the mouse in its cage a button. And that button, when it pushed the button, it shined a light in that region of the mouse's brain and activated the region of the brain that it would have been if they were taking drugs. And it gave them that little, like, dopaminergic hit. And they had to limit it because what they find is the mice will just keep hitting it over and 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 over again. And that's cool because you're actually studying the neuronal basis of addiction behavior. Now, Coffee, that same thing has been done in mice, but with drugs as well. There are regulations on how many times they can press that button in those kinds of studies. So, like, how many times can you press the button and get an injection of cocaine or something? That's limited in those studies. So you don't allow the mouse to overdose. You also don't give them so much of a dose that it would cause like any kind of negative long-term effect. But that was like one way to study addiction, like an addiction behavior, is to see if they learn, if they will have restraint or not, and then you can give them drug to see, okay, can you dampen the effect or benefit of that drug in terms of like the brain chemistry. And that's just like one of the features that people are studying. Okay, let's go back to the optogenetic front. And we might go through the methods of this paper too, because the methods actually are really, really cool.
And they did it. In 2007, scientists demonstrated this technique for the first time in a live animal by applying optogenetics to cells in the motor cortex of a mouse. By transmitting blue light down the optical fiber in the mouse's brain, they could make the mouse walk in circles and make it stop when they turned off the light.
Right, just think about that. You're shining a light on a particular set of neurons and you get them to walk. And then when you turn off the light, they stop.
Pretty weird. Many other studies also use optogenetics to study how cell activity correlates with behavior and bodily function. For example, in one study from the journal Nature, the researchers manipulated cells that put fruit flies to sleep and then could wake them up on command. Those same cells are involved in the fruit fly's internal sleep clock, which has neurons. In mice, researchers have also used optogenetics to study behavior related to hunger, which could help us model obesity in people. It even has a role in helping us understand and maybe someday treat certain diseases. Like back in 2011 in the journal Molecular Therapy, researchers claimed they'd used optogenetics to restore light sensitivity to cells in a mouse that had lost its vision. That could someday help develop human treatments for a disease called retinitis pigmentosa, which destroys light-sensitive cells in the retina and causes blindness. And another study from the journal Neuron pinned down specific mice neurons involved with motor control. In humans, cells in a similar part of the brain are affected by Parkinson's disease. Now, even though mice, rats, and fruit flies have brain structures with some features in common with humans, our brains are way more complicated to understand. We'll need a lot more work before we're ready to give people remote controls for their brains. Still, it's possible that someday, tiny optogenetic devices will be working away in our bodies, offering targeted therapies and cyborg-style nerve implants. We're definitely not there yet, but if it ever happens, just be careful not to leave the controls to your body lying around the house. If your cat sits on it, it might end up controlling you instead. Although really, I guess that's not much different from owning a cat today anyways. Thanks for watching this episode of SciShow, brought to you by our awesome patrons on Patreon. If you want to help us keep making episodes like this one, you can go to patreon.com/SciShow.
Why can't I just scrub all the anxiety from my brain, just give it a little scrubby scrub? So NMD, that is a goal.
I like your pants around your pants.
Vid gaming. Bit, the timing of that. I can't tell you why it's perfect, but I love the timing of that, my friend. I like your pants around your pants. Yeah, that was the lovely plain old Trey who was singing Pants Around Your Pants. Make sure to check out the lovely and breathtaking plain old Trey. Now then, chat. NMD's question. Why can't I just remove all the anxiety from my brain? Anxiety is genetically encoded. NMD, there is a genetic reason for it. We're going to get into that in just a moment. So you'd have to change your genetics to get rid of it. You'd also have to change, your anxiety is actually dependent on like what all you get anxiety of. It's not all also genetic, but it's also environmental and through your experiences. How your brain is wired to respond to anxiety and what gives it anxiety is different than for other people. And so we not only have to do genetic changes in your brain, but neuronal rewiring as well. So it would not be a little wash. It would be a deep wash that we'd have to do NMD. And there might be a negative consequence, right? NMD, like, would you say that there is benefit, right, to some instances of being anxious? Like, a new job, maybe, like, you know, that like, or like a big presentation, or if we're getting into the evolutionary side of things, if you're, you know, being hunted by a lion and you need to trigger that fight or flight response, that anxiety gets your heart going, and so you can just go and run. Right, that's not impossible. I like to be anxious in a car. There, see, exactly. So getting rid of it all the way, NMD, might not be beneficial. Anxiety is being productive right now. Zulu, why is that hype? All the drugs we take for anxiety, part of that wash with so many side effects. Yeah, and Grimly, it's going to be, because it's brain chemistry, right? You're messing with brain chemistry. There's no way of knowing what all is going to happen to it, short term and long term, but we know it's better than the alternative, right? At least I think so. Find anxiety between anxiety and excitement, roller coasters. I would argue a bit gamey. Roller coasters are also anxiety. It's just you are perceiving that anxiety differently. That is a non-natural state for you as a human to be in, and it is triggering your flight or fight response, I would argue. Because it should not be happening. That's just my thought. Pushing a button that make you sleep better than drugs such as Ambien would be able to awaken without someone pushing a button. So coffee, I think it means... Hi, little panda!
Hello there. Hello there.
I would suggest Coffee Rocks. That if you fire those neurons that push you towards sleep, unless you're continuously shining that light on the neurons, it should eventually fade and you should wake back up. Again, it's only a hypothesis, but that's one possibility of how it would work. I'm on the no anxiety side of the spectrum. It makes me a bad procrastinator. Kai, I used to be a lot less anxious, and then look at me now. Look at me now. Oh, the joys of medication. Little Panda, long time no see. How's everyone doing? All right, Little Panda. I hope you're doing well as well. We're talking about optogenetics and the heart and its connection to the brain. In fact, let me show y'all a video on optogenetics. Where is this video? Here we go.
When scared of culture that doesn't take mental health issues seriously. There's a lot of
run away.
Sorry, y'all. Everything decided to start playing. This is a cell culture. So this is a look at the actual heart of the mouse, and they're going to shine the light on it to make it pump faster. So this is an optogenetic experiment. So it's a regular pulse. And then now the light goes on. Look at that. Right by eye, you can see the difference in the pulsing of this heart with the light on. Light back off. Look at that. Do you see how rapid, like this is live, this is a live video. This is a live video of this heart. This is not sped up. This is not slowed down. This is just looking at, like, here is the heart. We shine the light on it, it pulses faster. We turn off the light, it goes right back. Which I think is quite remarkable. Anxiety of the mom, yes. NMD, if you want, we can jump to that for a second. Alright, give me one moment, NMD. Let me find. NMD, these are a little bit difficult to, because I didn't pre-screen the videos, and so I want to make sure the videos are not triggering. And I am not comfortable right now. Oh, hold on, this might be all right. Sorry, I couldn't find any of the usual video sources. Like, I didn't want to pull up a TED Ed or a TED Talk because I didn't know what their topic is about. But a SciShow video, I feel like SciShow has a good balance on that front. If it starts getting too heavy, y'all let me know. Again, I have not pre-screened this, but I feel like SciShow is one of those where I feel like I can go in blind and I can trust them. If it's too much, just let me know. But this again is looking at wow, yippee yo yippee, Snoop Dogg in the his ass. Boys! No, this video is not looking at boys. This is looking at intergenerational and transgenerational trauma being inherited. Boyd's Custom Fab and Geek Links, welcome on in. Chat, if you want to check out legendary Boyd's Custom Fab, Boyd's Custom Fab, amazing woodcraft extraordinaire. And one of the most handsome people in the state of Texas. We love Boyd's Custom Fab here. Chat, go follow Boyd's Custom Fab. He's an absolute legend. I have all my Boyd's coins on my desk as well. And Wicked Walnut stickers. And much more. Look, I'm even number 49 on some of these things, chat. Go check out Boyd's Custom. Oh, yes, NMD, look. You want Boyd's Custom Fab stickers. Unfortunately, NMD, there's not one of his face on said sticker. However, NMD, there is a drawn face sticker. It's Boyd's is Mr. Tumnus from the popular book that is called Lion Witch in the Wardrobe. But you can see Team Boyd, some of his kitties, his dancing right there. There's Team Walnut, Boyd's Custom Fabric, all the Fans Pants things. Work of art is from Babe Ross, aka Babe von Babenstein. Boys, I look at you every day. This whole desk, while it's a little bit messy, it is an homage to this amazing community. Boys, we're talking about, there's this new study that was looking at the connection between, you know, if you get butterflies in your stomach or your heart starts racing, and then you get really anxious. The question is, what is the connection, hi Keens, by the way, between that heart rate change and your brain? And what they find is you can actually turn on and off neurons by shining a light on them. For example, let me actually find the video. We're just looking at it. So boys, this is the mouse heart in a dish. And what they do in this is that right now you're seeing it as its regular pulsating state. It's gonna, at the top of the video, tell you when it shines a light on. But it doesn't, you're gonna be able to tell the difference. There, look at that. Light on. And light off. This video is not edited in any way, boys, beyond they just took a video of what was going on in the heart. So it is not sped up, it is not slowed down. That is honestly how tightly controlled we're able to do this. This is shining on the heart tissue. So what they wanted to do is to shine on the heart tissue and activate the heart and see what the corresponding information is that happens in the brain. And what they ended up finding, boys, is that the brain, the region of the brain that gets activated is responsible for the region that you have anxiety for as well. This is in mouse, by the way. This is in mouse. And then what's really cool, boys, they found that you can do the opposite, right? You can actually put into the brain another light. So you have one in the heart, one in the head, and that light could be to turn off neurons, right? And so what you can do is, if turning on heart neurons, or heart cells, turns on that region of the brain that causes stress, if you turn off those neurons that cause stress, all of a sudden, the heart returns back to normal. So they're looking at the connection between stress, the heart, and the brain, which is, I think, quite breathtaking. And then we had a question, boys, from NMD about how stressful things can be inherited over generational time. And so that's what we're looking at now. That's definitely a rabbit hole, boys, but we'll get back to the heart question in a moment. They have human trials for this kind of testing, or they don't have it in lab animals. So, boys, this paper just came out. The idea will be to do something like this in humans as well, if you are able to turn off neurons or turn on ones that maybe control, like, fear response, fear memories, stress, PTSD related events. That would be a great thing to be able to put in and like log into the brain and fire up or turn off those neurons. But to my knowledge, boys, there's been so far as we've put in human cells in a dish, we've turned those on. But what we have not done, boys, is we've not put it into an actual human. It's been in human cells. It's been in whole animals such as mouse and rat and fly and worm and zebrafish, but not in like a whole human. I think stress carries over DNA like some degree. So yes, but evil petty. I think what NMD wants to know is like more short-term effects. So like trauma can transmit between generations, but that's not a feature of the DNA sequence changing, but rather the DNA expression changing and the 3D structure of it. Possibilities are limited, it can be understood. Yeah, and so boys, we're trying to understand it something more simple like a mouse, and then translating it into a human. But like even a mouse isn't simple. Speaking of neuroscience, folks, make sure to please follow our amazing friend by the name of Neurolecia. She is another science communicator. Her specialty is is neuroscience. Please go drop her a follow. Another science communicator here on Twitch. Go drop her that follow. All right, let's talk about NMD's question here. And yes, Gwendolyn P. J Brain Z. Thank you for the follow, J Brain Z. Welcome on into the colony.
There's no getting around the fact that bad things happen to people, things that are often outside of their control. And the psychological effects of wars, natural disasters, and other types of violence and accidents don't just go away when the war ends. They can leave people traumatized. Many people who are exposed to traumas like war get diagnosed with post-traumatic stress disorder or...
The mice are okay, so NMD, it depends. That heart... So you can do heart tissue in a lot of different ways. You can do heart tissue. Jay, thank you for the biddy, Jay. How you doing, Jay? First time chatter. Welcome on. You can grow heart tissues in a dish. NMD, independent of killing any mouse. It's called an organoid. It is an organ-like structure that you grow in a dish. That's one possibility. Or they can also remove the heart from the animal and test it like that. I cannot remember how exactly they did that experiment. TD Fox, you have a question for the ferret? You got it, TD Fox. Hold on. Hello, TD Fox! Your question is, what is your food? Is he starving you? TD Fox, I do not eat food. I feed on love. If you believe in me, if you show the ferret kindness and love, and you are kind to two people in the chat, that is what I feed off of. So as long as you're kind, I'm kinds of full of delicious food. I do not eat other real food. I have data to eat, and when I make poops, I have data dump. TD, thank you for asking that question. When they stress out the mice, do they unstress? So NMD, one unstress that they do. Thank you, Andrew. One stress that they do, or de-stress, is actually turn off the neurons in the brain that connect to the heart, in the sense of like the feedback loop, and that calms the mouse down. They also, once the experiment is done, they put the mouse back into a container and it's fine. Sometimes the mice do need to be sacked, NMD. That means a ethical means of putting them to sleep. And that, when done, it's for the good of the mouse. It's just that there'd be like no way to make sure the mouse is no longer in long-term pain. And so that does happen too, and there are procedures in place to make sure that the mouse does not feel anything. We're not going to get into what those are because I feel like that's a little bit triggering. But there are things to keep the mouse comfortable and not in pain, which is, I think, very important to do. All right, NMD, to your question, man.
Or PTSD, where thoughts or anxieties about the events can plague them in other parts of their lives, and seemingly benign things can trigger a fear response. But hopefully, once a war goes down in history and a few generations pass, we'll be free of the trauma, right? Unfortunately, it's not so simple. Trauma can affect future generations too. For example, in a study of 100 Holocaust survivors, researchers found that their children were more likely to get a PTSD diagnosis, even though they didn't report any more traumatic experience in their lives.
So this NMD, I think, is really getting at your question, right? So like in utero, how can those translate to like negative experiences in utero to adulthood as a child? And this is one example of it. So it's a very strong example of PTSD diagnosis, but the research sometimes NMD is a bit on the controversial side. There's also preliminary evidence to suggest similar things happen with the World Trade Center events as well, that also led to a PTSD diagnosis in those babies
Than a similar control group did. What they did get was stories from their...
Jay, thank you for the biddies. Have you ever heard of MRSA? I want to become a biology teacher. Yes, a metatarsal-resistant Staphylococcus aureus. Yes, that is a thing. It 100% is a thing. Thank you for hiding in the shadows. Love your face, Oxfixon.
Parents, really distressing stories. And hearing about threats to your family, even in the past, can be traumatic on its own. But that might not be the only explanation. Trauma could also be inherited biologically, sort of like what gets passed on through our genes. And since a big part of understanding people is knowing about the different factors that can affect their thought processes and behaviors, psychologists want to figure out how this works. So far, we do have some evidence that trauma can be passed biologically from one generation to the next, but it's very limited. A lot of it comes from a study published in 2015, where researchers did some genetic tests on a sample of 32 Holocaust survivors, 22 of their children, as well as a demographically similar control group. They were looking at what's known as methylation of the genes, where a DNA molecule gets a sort of hop-on called a methyl group. If a gene has a lot of methyl groups attached to it, they can create problems with copying that gene, or it can keep the gene from doing what it's supposed to do.
So that Lelina, it's very difficult to study this in humans because your controls really aren't that good, right? You have no way of knowing everything that people went through in life. So there's an absurd number of factors that could be playing in, which is what makes these studies very difficult to interpret. But I think, you can glean some insight as to what might be going on the genetic level here. And again, it's not mutational state, but rather it is changes in the state of the DNA. So that methylation closes up regions of DNA and makes them inaccessible to turn those things on. Thank you for the biddy, Jay. Nice, seriously, I'll be checking back in. Appreciate you, Jay. Let me scroll back up. Sorry, y'all. Evil Petty Mike says, I have PTSD, can't wait to one day not have it turn into PTG, post-traumatic growth, working on it. Evil Petty, I'm hoping that there will be a time where we're able to either use drugs or these kinds of components to turn off those phenomena, and just instead of having to deal with it, we can just get rid of those, selectively get rid of those memories. There are labs working on it, so fingers crossed something like that will happen. Would depression be in the same way as being genetically passed down? So Becca, it's hard to say if that is the same. There just hasn't been a lot, there's no real good study done on humans, right? There's so many variables in humans. The closest thing that you can do is you can modify and induce depressive-like states in mouse models, but that's also questionable. It doesn't necessarily translate the same way, but there has been a connection shown, at least in anxiety and high-stress situations, to be inherited in the next generation. So if during your depression, when you're pregnant, or if you're pregnant during depression, undergoing high amounts of anxiety, that might. And we had a question from Andrew CZ earlier in the chat. Andrew asked, so one hypothesis that they were trying to get rid of is to activate certain neurons with either drug or light to get rid of selective memories that could be negative and trauma-induced. Again, Andrew says, what would be the unintended consequences of getting rid of memories that might be related to some degree of emotional stress? And that, Andrew, unfortunately, is not known, which makes it really stressful, right, Andrew? It's well, you're like, Belinda, what could happen if I took this and I got rid of my trauma? What would happen? Unfortunately, Andrew, we don't know. That's why it's not yet being tested in humans. A lot of it is being tested in mouse and rat models, including the drug that I was talking about and the genetic modification of ACSS2. What's unfortunate is, Andrew, we can't ask the mouse how it's feeling or the rat how it's feeling post-treatment, which makes it all the more difficult, right? Because if you could ask, then that might be a way that we can account for some of these extra variables. But unfortunately, there's just absolutely nothing that we can test for. And so there's going to be weird unintended consequences. And what makes it even harder, Andrew, is we don't know, right, how experiences will play into this. So, how when you, if you've gone through certain events as a person before the trauma, right, and then you get rid of some potential memories, how that's going to be influenced as well. And it's just, that kind of treatment, it's hard to know, right? And there's psychology, there's biology, there's physiology, there's genetics. I guess, Andrew, I would argue it like this. If you have something really, really traumatic and you have the opportunity of getting rid of it, would you go for the opportunity to get rid of it with potential side effects? Maybe in some instances you would still go for it. Like, it would be better to live with other potential side effects than having this memory constantly triggering. And that would be one thing to suggest. But you're right, Andrew. There is... that is a very good question. And unfortunately, Andrew, that's a question that's asked in a lot of these treatments. Because especially, I mean, you're going from mouse models, right? Which, yes, do inform a fair bit of biology, but they're still different. And so it's sometimes hard to have that connection there. But very great question. Can have depression familial, like aunt's depression, mother does not, but child does. Yes, Coffee Rocks, there also are skipped interactions and genetics on that front as well. And Coffee, those are really difficult to figure out as well. Like that is another genetic component that we're fully unaware of and how it necessarily works. But it's something to keep in mind that those might be distinct from these experiences here. Okay, let's continue for the lovely NMD, and then we'll get back to our heart.
Studying methylation is part of the field of epigenetics, the study of what can be inherited or passed on from parent to child biologically, but outside of the actual letters of your DNA. Since methylation levels can change based on your environment, it's a way things that happen in your life can affect what you pass down. And the researchers found that compared to the control groups, both the Holocaust survivors and their children had higher methylation levels in a gene related to stress response. Previous research showed that gene was related to an increased risk in developing a psychological disorder like PTSD in people who experienced some kind of trauma in their childhood. So the team thought they might have found a biological way for trauma to be inherited through increased methylation that gets passed on. But there are some problems with this study. Among other things, this
See, there again, so it's NMD, don't read too much into this study because, like they said, there's a bunch of issues with it. Gonna go into migraine management. Have a good one, Neuralicia. Love your face. Thank you again for the raid, madame. You are breathtaking. Next Twitch science partner right there in the making, Neuralicia, folks. Go drop her that follow.
sample size was pretty small, and we'd have to look back a few more generations to see if the methylation changed when the trauma happened, or if it was always higher in that group.
So NMD, to really get at, like they were saying, the biology of this and prove that that's what happens, you have to go back in genetic time. You'd have to test not only the individuals there that are affected with the trauma, the offspring. You want to check the parents, their parents, their parents' parents, and do a giant comparative study. It's just the data is so small. It's like, yeah, you're comparing. What they did was they compared the trauma group to a control group, but they are not genetically related, so you don't know how they're, like, what interactions and how they work together. So there's a lot of things in this study that are wrong, like not wrong, but like not filled out enough where you should be comfortable making real conclusive statements. Which is right, NMD, which is like, but it's so cool and I want to. But to be, you know, we gotta go easy on that and make sure that we know and we ask the appropriate questions, and when we ask the appropriate questions, that we're not getting overzealous in what we're trying to do.
So the evidence so far is kind of tenuous, and we'll need a lot more research before we know for sure. That said, the idea that trauma can be inherited isn't too far-fetched. We know that other chronic stresses can have an effect on children, sometimes through a biological mechanism. But even
Ezra, they could have definitely done other generations depending on what populations they're looking at, but I think the difficulty is any kind of human study is inherently gonna be difficult to get interpretations and experimentation out of, because you don't really know what factors are really acting on these features. Like, what is really the big question, and how is it truly affecting? I don't know. And Ezra, I think, you know, with the environmental factors at play, maybe no one knows, right? Because imagine what you go, because we know that diet, for example, affects the gut microbiome, which affects neurons, which affects behavior, which could affect epigenetics, right? So Ezra, imagine like if diets change across generations, which we know they do, how those will translate into changes of thing like that we're studying here, right? So versus if you study a mouse or a fruit fly or something like that, you can keep a hold of them in a lab atmosphere and make sure everything's controlled so that you know exactly what factors are being changed, how they're being changed, and what gives you the best possible answer, like in terms of like clean science, if that makes sense. But I agree with you, Ezra. They could have sampled other populations who've also gone through trauma, but then you're also trying to compare traumas and say if they're equivalent or not, right? And so if one trauma is different from another, that could have different methylation sites on the DNA, and that doesn't disprove that your hypothesis. All that might do is say there are different kinds of trauma. And so it gets really hairy and really difficult to interpret really quickly as you introduce more variables. Always something to keep in mind with doing any kinds of these studies.
Even if we never find a biological way to explain how parents who've experienced trauma can pass it on to their kids, there's a much simpler explanation that has a lot more research to back it up. Usually, parents shape a lot of the environment their kids grow up in, which can make a big difference when it comes to their mental health. We know this happens with some clinical conditions like depression. Depression can run in families, and we know about some genes that might be risk factors. If one person gets diagnosed with depression, it's not only more likely that a child will get a diagnosis, but also that a grandchild will. But even in cases in which there isn't this long family pattern, having a depressed parent has effects on a child's functioning, like how well they handle daily life stresses. You can see similar patterns with alcoholism. Even though there's a known genetic element that makes children of alcoholics more likely to be alcoholic themselves, there are other ways people can inherit that stress from their parents. Having an alcoholic parent makes people more likely to show higher neuroticism, psychiatric stress, and aggressive behavior in adolescence. But the thing is, it makes a difference whether that parent is a recovered alcoholic or not. Meaning, it's not just their shared genetics. The environment the child is living in can put them at increased risk.
And this is NMD, why these, again, another reason why these studies are so difficult to interpret, because there's so many additional factors that are also playing in from the outside going in. It's not just straight genetics, it's a lot of different things.
And if a parent experiences
reason why my husband has never had alcoholism runs in his family, doesn't want to chance it. And what's wild to leaning it, right, is that even though he's never had any, if his parents have, it can still affect the kids. Like, there are pieces of evidence that demonstrate there is some generational jumping that can happen as well. But if you're setting up an environment where that's not really available to the kids, it can potentially mitigate it. Again, it's just, there's so many different factors at play. It's just not easy to explain. And it's why it's not as easy to explain in a mouse where you're controlling everything. So that's why humans and MD, that's why the question that you ask, it's a great question, but it is so difficult to actually answer.
Experienced trauma that can have a big effect on their kids' environment. For children of Holocaust survivors, for example, even hearing stories from their parents could change their view of the world. So we know there's a risk that's carried to children, even if the epigenetics idea turns out to be a fluke. But it's also important to remember that a risk factor isn't an equal sign. Having a parent that experienced trauma or had a clinical disorder doesn't mean you will too. Research shows that things like promoting positive parent-child interactions and teaching coping skills to children of depressed parents can reduce some of these risks.
Interestingly enough, about anxiety risks, it's actually been shown, there was some studies, if you hold your developing child more in the first 3 months of life than just letting them cry it out, they're less likely to have depression as adults. And the hypothesis for that is the baby cries due to anxiety and thinking that it's alone. And if you hold the baby and comfort it, then it'll be less likely to think that it's alone. And that somehow translates to long-term decrease in potential anxiety. So that's another way, like, how environmental factors are affecting your anxiety levels and your potential disposition for anxiety, is what is being done to you as a baby in terms of how you're being held. So actually, a lot of modern day child psychologists are going against now the idea of letting your kid cry it out, but rather the argument is that, you know, in the wild, when we were still hunter-gatherers, you didn't leave your kid in a random bed as you went off and got food, because like an animal might eat your kid or something like that, right? And so instead what you would be doing is you'd have your child with you. And so only since like the 30s and the 40s have we really, like, when we've shifted to like these 8-hour work days and everything, gone to the idea of crying it out. And so it's not really biologically significant, and people are discovering that. So it's, again, NMD, environmental factors of anxiety, is at the start of life, ma'am, which is wild to me.
So even though kids are at risk of inheriting some negative consequences if their parents have experienced trauma, it is certainly not inevitable. Thanks for watching this episode of SciShow Psych, and if you're interested in learning more about the science of epigenetics, you can check out our video about it on the main SciShow channel.
NMD, I hope that answers your question. We're gonna cut back now to a little bit more about the mouse study, or actually, this might be a good look at the anxiety connection. Here we go. About general stress, and because again, this original study that we're chatting about is the connection between the heart, fast pumping of the heart, and its connection to the brain, and anxiety. Never really understood crying out. Your baby is crying, they need something. As the parent, it's your job to make sure their needs are met. So I think the justification have been, the Lenina, is if you let them cry it out, they recognize that their crying doesn't immediately gain attention, and they maybe will stop crying and they sleep through the night. But so I think it's more of a convenience thing, maybe, the Lenina, rather than something rooted in biology. And I agree with you. If the kid's crying, there's probably a reason why they're crying. At that really young baby stage, they don't, like, that crying is because they need something, right? And it's like you're saying, Lillian, it's your job to make sure that they're okay. Like, you want your baby to eat, you want your baby to sleep and poo, and, like, you know, they can't tell you what's wrong. They can only tell it you by crying. So, like, you know, baby Alona crying, and I'm like trying to figure out what's wrong. Like, I don't know, maybe it's a dirty diaper, maybe she's, you know, constipated, maybe she's hungry, and it's like, you know, we just trying, and yeah, but it's different thinking of different places. Absolutely, NMD, and it's not really a crazy total rabbit hole. It is connected to this idea of anxiety. Remember, our paper that we're looking at right now is talking about the connection between you know, the heart and a behavioral state of anxiety. Self-soothing response by my parents believed in it. So coffee, it seems like self-soothing is more likely to occur in like as you're like once you're getting older, like the 3-month stage, 2 to 3 month stage, when it apparently starts. I know the little one, she's starting to self-soothe maybe in the past like 2 weeks. And so, like, she might wake up in the morning and she might start making noises, and Lita looks over, but then she might fall back asleep because she just, you know, self-soothes. But before that, it was a and then it's like, okay, we're here. And then, you know, it would be, you know, like, you're here. My God, she was so tiny. She is so much bigger than this. This is like the first week of baby Alona right here. And now she no longer fits right here on my chest like that. She's like sprawled out the whole time. It's Lenina, they grow really fast. I'm glad she's growing. I want her to keep growing and you know, healthy and whatnot, but it's just like, whoa, you grew fast, little one. NMD asking, you shall receive, ma'am. I know, I saw Risk, though. I'm sorry I couldn't answer your Discord message. I try. not to talk on Discord when we're live, because that's a little bit difficult to do, and my attention can be split. That's a giant split. But yes. Look, Smikes even said I had a lovely shirt today. Rista Rock. So we're just going to quickly talk about MD, how stress is connected to the rest of your body. We'll then talk about the mouse stress that they did in this paper, and then we'll talk about, again, tie it back to that optogenetics and what all they found. Basically, again, they found a region of neurons that if you then deactivated it would fix the stress induced by the heart stress. You never I know, Andrew, listen. What I do is shout out to breathtaking amazing people, for example, such as Andrew CZ, breathtaking extraordinaire fitness gentleman, handsome as ferret, technological wizard, and one of my
best friend.
That's right. Yeah, Risto. It's exclamation point BFF, Risto. Risto exclamation point BFF. You can even at someone, Risto. BFF at someone. And trigger that animation now. And call someone, Risto, your best friend! For example, Risto. Like that.
My best friend.
Yeah, Risto, I don't get it either, but you know what? It makes me laugh, it makes me chuckle, and it's fine. It's fine, Risto. It's fine. Let's get into some anxiety here and stress.
Cramming for a test? Trying to get more done?
Just as an aside, this image stresses me out.
Than you have time to do. Stress is a
best friend.
Thank you, Risto. Risto, that sound clip is from an anime, in fact, Risto Rock. An anime, even, Risto. If you look it up, Risto, if you want, I can show you what anime it's in. It's actually quite a silly scene. It's like two sumo wrestling dudes are about to fight, and one goes, "You're my best friend!" It doesn't really make much sense, but you know what? I'm there for it.
Feeling we all experience when we are challenged or overwhelmed. But more than just an emotion, stress is a hardwired...
A mouse heart, and it can be turned on using light. And so this is the normal heartbeat rate of this mouse, and they're going to shine a light on it. You're going to see when they shine the light on it, it's going to pick up the pace like mad. Wow! Look at that. And they're going to turn the light off. And now it's pulsing back at normal. So why they're doing this is because there is a connection between how the heart beats. So you know, like Suno, when you say, let me get you the exact quote, because they use the quote in the paper to justify why they did this. When you're stressed or anxious, you might feel your heart race. And is your heart racing because you're afraid, or does the speeding heart itself contribute to your anxiety? That's what they were trying to ask. And what they found is, Suno, that they can turn on that rapid heart rate in the mouse using a laser, and that will turn on neurons in the brain that correspond to anxiety. And what's wild is you can actually cut a hole into the mouse skull, connect on a laser, and turn off those neurons that are causing anxiety, and that in turn will slow the heart back down. So it's a chicken or an egg question, but it's getting at some like features and possibilities of having anxiety and where they stem from. Like, is it all controlled in the brain? Is it coming from other sources as well? Like, you know, like how you say I have this like pit of my stomach feeling. Suno, there's actually been studies that show a connection between stomach health as well as your brain and anxiety, which is quite wild to me as well. Purposely clenching and unclenching muscles can make you relax a bit. Research in anxiety, that seems an interesting study. Doesn't it, Suno? Chicken or egg please, with bacon. I don't have any, Barty, because I don't know why. We usually don't have bacon, but we do have eggs here if you want to come over. Guys, also go check out Supernatural Writer, workout streamer, beauty streamer, co-working streamer extraordinaire. We very much love you, Supernatural Writer. Hello, hello. And so Suno, we're now talking about just how the body is infected overall and by stress and anxiety, and then connecting it back to the mouse study that they did, where they actually induced the stressive behavior with learning and memory and lasers, and then try to ask how all that works. All the anxious stuff we deal with, this seems a decent insight on how those neurons work. Exactly, and Suno, now that they know the exact neurons to turn on and off, that is a big clue, and these neurons are conserved from mouse to human, and that's a potential avenue for treatment. Like, if you can imagine that if we had a drug that intentionally modulated those neurons that we identified, maybe we can help combat stress. I have to go again, heading to the airport. Be safe, Barty. I wish you were coming here, Barty. But have a lovely journey, my friend. I'm going to miss your face. Please be safe. Love you, Bardaki. All right, let's get a little bit on the stress and how it's affecting the body. Texas. Bit Gamey, did you know everything's bigger in Texas? Yeah.
Cramming for a test? Trying to get more done than you have time to do? Stress is a feeling we all experience when we are challenged or overwhelmed.
Actually, Bit Gamey, that is not true. If you were in Massachusetts with that same paycheck, you couldn't even afford a box to live in. So that's the one big benefit of the southern United States, is that dollar goes further. So even though the amount might not be different than in Massachusetts, it's bigger because you can afford life. That is a silly Belentism, but that's one thing, Bit, when we were looking at postdoc positions, a lot of people were like, go to California because there's a lot of great labs out there. And our first question was like, yeah, but how do we afford life? And some of the professors we asked, Bit Gamey, were like, well, you just ask your parents for money. And we're like, that's not always an option for people. You know, it was very strange, Bit Gaming, of like the attitude that people had in research labs and how what they thought was a appropriate response to that. And it was like, we can't just be asking our parents for constant money. And yeah, it was a whole thing, Bit Gaming.
But more than just an emotion, stress is a hardwired physical response that travels throughout your entire body.
You must not belong to California if you're not entitled. I mean, Andrew, like, one reason we really heavily looked at Cincinnati as a potential place for a postdoc is because, number one, they had good labs, but also we could afford stuff in Kentucky. And, like, you know, these are important things to consider. And it's just, there seems to be a disconnect between some ideas of what you think is beneficial enough to go for in terms of a future, like from a financial perspective, but also from like the job perspective, and they don't always tie. I think our professor in grad school, his wife did not work when they were in grad school, so she was staying at home and taking care of the kids, and her parents gave them a lot of money. And so I think that was his expectation of people in his lab as well. It's like, why would you not go all out for a job when clearly this could be done for you as well? Which I would argue isn't necessarily the case. But
in the short term, stress can be advantageous, but when activated too often or too long, your primitive fight or flight stress response not only changes your brain, but also damages many of the other organs and cells throughout your body. Your adrenal gland releases the stress hormones cortisol, epinephrine, also known as adrenaline, and norepinephrine. As these hormones travel through your bloodstream, they easily reach your blood vessels and heart. Adrenaline causes your heart to beat faster and raises your blood pressure, over time causing hypertension. Cortisol can also cause the endothelium, or inner lining of blood vessels, to not function normally. Scientists now know that this is an early step in triggering the process of atherosclerosis, or cholesterol plaque buildup in your arteries. Together, these changes increase your chances of a heart attack or stroke. When your brain senses stress, it activates your autonomic nervous system. Through this network of nerve connections, your big brain communicates stress to your enteric or intestinal nervous system. Besides causing butterflies in your stomach, this brain-gut connection can disturb the natural rhythmic contractions that move food through your gut, leading to irritable bowel syndrome, and can increase your gut's sensitivity to acid, making you more likely to feel heartburn. Via the gut's nervous system, stress can also change the composition and function of your gut bacteria, which may affect your digestive and overall health. Speaking of digestion, does chronic stress affect your waistline? Well, yes. Cortisol can increase your appetite. It tells your body to replenish your energy stores with energy-dense foods and carbs, causing you to crave comfort foods. High levels of cortisol can also cause you to put on those extra calories as visceral or deep belly.
Zulu, the animations are also quite stressful when they're animating and demonstrating stress, and this is just what happens to your body. Well, let's talk about what happens to your brain during times of stress in just one moment, and then we'll connect it back to the mouse studies.
Belly fat. This type of fat doesn't just make it harder to button your pants. It is an organ that actively releases hormones and immune system chemicals called cytokines that can increase your risk of developing chronic diseases, such as heart disease and insulin resistance. Meanwhile, stress hormones affect immune cells in a variety of ways. Initially, they help prepare to fight invaders and heal after injury, but chronic stress can dampen the function of some immune cells, make you more susceptible to infections, and slow the rate you heal. Want to live a long life? You may have to curb your chronic stress. That's because it has even been associated with shortened telomeres, the shoelace tip ends of chromosomes that measure a cell's age.
Although, just as an aside, folks, the telomere length isn't the only thing that matters. In aging, it's been shown, like, if you restore the telomere length, it doesn't always correspond to an extended lifespan, and short telomeres don't necessarily correspond to you dying soon. It's just some features to kind of keep in mind. This is why I'm kicking myself. It's taking 35 years to decide that I need a therapy, despite my therapist's insistence that I should not be kicking myself for things. Yeah, Zulu, unfortunately, part of our own nature, right, is to not kick ourselves. I know my mods are very on me for my constant self-deprecation, but that's also one of the things I think dealing with my stress is like, oh, well, I'm a dummy item, it's fine. And then that constant kicking yourself on it is also not good. So there's a lot of medical problems that could happen there.
Hey, Belen, it's time to say something nice about yourself.
I know, Andrew, you are breathtaking and handsome, so fit, and I'm lucky to have you in my life.
To allow DNA to get copied every time a cell divides without damaging the cell's genetic code. And they shorten with each cell division. When telomeres become too short, a cell can no longer divide, and it dies. As if all that weren't enough, chronic stress has even more ways it can sabotage your health, including acne, hair loss, sexual dysfunction, headaches, muscle tension, difficulty concentrating, fatigue, and irritability. So, what does all this mean for you? Your life will always be filled with stressful situations, but what matters to your brain and entire body is how you respond to that stress. If you can view those situations as challenges you can control and master, rather than as threats that are insurmountable, you will perform better in the short run and stay healthy in the long run.
And then, let's talk about how stress affects the brain. And again, then we're going to link it back to the mouse studies, in particular the stress, learning, and memory system that these animals were undergoing, to then they were then tested for their, the optogenetically to turn off neurons both in the heart and the brain and see the connection between them. It's not borderline nice, Andrew. That was a very nice thing I said about, because I am blessed enough to have a friend who's amazing as you are. And that is a commentary on me, because you would not be friends with any old jabroni, I feel like you have a radar, Andrew CZ, that is unlike any other. And because of that, I am grateful to have you as a friend.
Are you sleeping restlessly? Feeling irritable or moody? Forget.
My best offender! Hi, KK. Where are you packing? Where are you going, KK? What are you doing, KK? KK goated going on. KK, I never know how to say the whole thing on that, but I hope that your packing is going well and that you're amazing and breathtaking. We've been talking a lot of neuroscience today, including a new study, KK, about the connection between cardiogenic control and effective behavior. So using Optogenetics to fire and speed up the heart and its connection to the brain, that you can then counteract and lower stress back. It's a really cool mouse study. Think you'd be all about it. Welcome to Heck In, KK. It caused me to chuckle. Listen, Andrew, you are, Andrew, one of mine.
My best friendo.
In dreams, one is not tethered by earthly limitations.
What does that mean?
Come.
NMD 96, the hero. Please sleep well. Have a lovely evening. NMD, folks, is a breathtaking person extraordinaire on her partner Poosh. Go follow NMD 96. You never know when she might go live. You never know. She doesn't like to post when she goes live, but if you join our Discord, there's an auto post of when she goes live, so you will know when she goes live. And you know, make sure, NMD, you sleep well. You do not let the EU slip through your fingers again. Okay, chat. One thing NMD is very not great about is the EU constantly slipping through her fingers, just like the ABBA song. Not the rhyming scheme, ABAB, but or ABBA, but rather coming on through that front, you know. Doesn't know how to do things. Illy you, NMD. Illy you, NMD. Have a great one. Just remember, NMD.
My best friendo.
Sleep well, NMD. Sleep well. All right, let's see how stress affects your brain, folks. And this is terrifying because I know my brain is constantly affected by stress.
Are you sleeping restlessly?
Indeed, Skip. How you doing, Skip? Skip, how you doing? Skip, did the studying is going well, Skip? Guys, Skip is a college man, and he's working on his studies. Skip, I hope the studies are going well and that the you're feeling ready. You're feeling ready for the big exams coming up, Skip. I hope those are going well. I want you to know how handsome you are, how breathtaking you are, how much we love your face, Skip. The breathtaking and amazing. Skip, a.k.a. occasionally skipped a bell.
Feeling irritable or moody? Forgetting little things and feeling overwhelmed and isolated? Don't worry, we've all been there. You're probably
stressed but alive?
Just stressed out.
Skip, did you come in at the perfect time as we're talking about stress? Possibly, potentially, Skip.
Stress isn't always a bad thing. It can be handy for a burst of extra energy and focus, like when you're playing a competitive sport or have to speak in public. But when it's continuous, the kind most of us face day in and day out, it actually begins to change your brain. Chronic stress, like being overworked or having arguments at home, can affect brain size, its structure, and how it functions.
So lots of things affecting your brain on that front with respect to stress. Look, since you got on, I've actually got to get off early morning. Skip, have a great day today. If there's any snow still, please drive safe because you stressed me out with your snow life. And guys, go check out Skip, aka Skip the Bell, who is not only an artist, a gamer, a Gucci legend, but an absolute gem of a person. Go check out follow the amazing, lovely, and breathtaking Skip. No snow's been nice. Thank goodness, Skip. Thank goodness. Running for a bear, stress is gate for that. Indeed, KK. Although, what kind of bear? Because I feel like you probably don't need to run from a panda bear. Now, black bear, probably. I actually came across a black bear, KK, in New Hampshire, just walking around in the woods. And we looked at each other and we had a great old time. I freaked Lita out and my family out because I sent them a picture pictures of the bears without any context, and they were like, "What are you doing? Get out of there!" And I was like, "No, it's fine. It's fine. It's fine. It's fine." And it was fine, KK. But it probably in hindsight, I should not have stopped to take photos of said bear, because it's probably not the best thing to do. Possibly, potentially, maybe. As a polar bear, that thing is gonna get you, or it's not. Your fate is in the hands of a bear. Wait, polar bears are kind and they don't get you? KK, you teach me something every time. Sleep well, Risto. You're really tired and a bit sunburnt, Risto. Do you have any Aveeno, Risto? Do you have any Aveeno, Risto? Risto, I hope you have some Aveeno to put onto your skin to get a little moisturizer on there. That'd probably be a good thing to do, so that I don't worry about you, sir. But have a lovely evening, Ristrock. I appreciate you and love your face.
Right down to the level of your genes. Stress begins with something called the hypothalamus pituitary adrenal axis, a series of interactions between endocrine glands in the brain and on the kidney, which controls your body's reaction to stress. When your brain detects a stressful situation, your HPA axis is instantly activated and releases a hormone called cortisol, which primes your body for instant action. But high levels of cortisol over long periods of time wreak havoc on your brain. For example, chronic stress increases the activity level and number of neural connections in the amygdala, your brain's fear center. And as levels of cortisol rise, electric signals in your hippocampus, the part of the brain associated with learning, memories, and stress control, deteriorate. The hippocampus also inhibits the activity of the HPA axis, so when it weakens, so does your ability to control your stress. That's not all though. Cortisol can literally cause your brain to shrink in size. Too much of it results in the loss of synaptic connections between neurons and the shrinking of your prefrontal cortex, the part of your brain that regulates behaviors like concentration, decision-making, judgment, and social interaction. It also leads to fewer new brain cells being made in the hippocampus. This means chronic stress might make it harder for you to learn and remember things, and also set the stage for more serious mental problems like depression and eventually Alzheimer's disease. The effects of stress may filter right down to your brain's DNA. An experiment showed that the amount of nurturing a mother rat provides its newborn baby.
Doesn't it, Grimly? And it's kind of scary, right? It's a little bit too much. It kind of feels like it hits home a little too much, and it actually makes me more stressed about being stressed, which is then like a circular going argument.
Plays a part in determining how that baby responds to stress later in life.
And yeah, so this is what we were talking about earlier with humans as well, right? Depending on how much care and response you get as a baby, like even up through like 1 to 3 month stage, that could influence the amount of stress you have later on in life. Now, which is kind of wild. No wonder I act like a T-Rex. KK, you act like a breathtaking, amazing soul. Black bears are skittish, very unlikely to attack. Grizzly bears are more aggressive, so will consider you food. And brown bears are unpredictable, so it depends on that brown bear. Gotcha, Alex. Yeah, I think it was a black bear. That probably explains why I'm still here today.
The pups of nurturing moms turned out less sensitive to stress because their brains developed more cortisol receptors, which stick to cortisol and dampen the stress response. The pups...
I see you, Zedman. You see this, Zedman? You see this beautiful shirt? Yeah. Right there.
Of negligent moms had the opposite outcome, and so became more sensitive to stress throughout life.
So again, childhood experiences makes you more susceptible to stress throughout life. Guys, if you're not checking out Looking Cool Zedman, the breathtaking soul that is in here in the chat, please go drop that follow. And if you like my shirt, use that link right there. Love your face, Zedman. Hope you're having a wonderful day, sir, you handsome devil. Zedman, did you know?
My best friendo.
You're one of my best friendos. Hi, Melissa. Melissa, how was your stream tonight? Were you safe Melissa. In the driving tonight of the Mario Kart, did you get the dubs, Melissa? Melissa, will get your fancy fan shout out as soon as the Gucci cooldown is done. Melissa, we'll get you your fancy pants shout out as well.
It's Gucci.
Lots of Gucci-ness going on. Alex, thank you for yeeting. For yeeting the lovely Kevin. You know, sometimes he needs to be yeeted, yut, I think is the terminology, Alex, but you know, he always comes back. He always comes back.
These are considered epigenetic changes, meaning that they affect which genes are expressed without directly changing the genetic code. And these changes can be reversed if the moms are swapped. But there's a surprising result. The epigenetic changes caused by one single mother rat were passed down to many generations of rats after her. In other words, the results of these actions were inheritable.
Not just across one generation, but multiple generations. And we've talked about that with fruit flies as well as with nematodes, C. elegans, across up to 5 generations. It'll still be inherited. I got to a point where I had to turn off my camera because someone was flustering me. Melissa, do we need to defend you and your honor, Melissa? Melissa, should I be angry? Let me know, Melissa. How should I label a box containing a robot vacuum, assorted things for my desk, some COVID tests, and a single roll of toilet paper? KK, I would label it like this. That's how I would label it. For me, KK. That sounds like a very, very sad box. Gracie Cat! Hi, Gracie. Hi, Gracie Cat. Gracie, hi. Hello, Gracie Cat. Hello there, Gracie Cat. You breathtaking, amazing soul that is Gracie Cat, folks. Gracie Cat.
My best friend.
Hi, Gracie Cat. If I had anyone, anytime, anywhere, I said that I would go fight nature communication people for my lab mate today. They are, I wouldn't fight with them. They have a lot of money. That, KK, they say they're not a parasitic journal, but they are loaded. They are loaded, madame. Chat, if you're not checking out Melissa with all the numbers, please go check out Melissa with all the numbers. Gamer extraordinaire, one of our best friendos. Melissa, I love your face. Your face, Melissa. Love your face, Melissa, with all the numbers. And KK, if you definitely need an army behind you, you just ask, and we will come and help. With our swords. And even with our Nerf guns. Your money can't do anything about my tiny fist and Tasmanian devil disposition. KK, I think you need to reevaluate what money can do for life. I feel like you're not around enough money to make that kind of statement. And once you see the nature funds, you'll be like, you know what? They really can do. They can actually take Benjamins and wrap your tiny little fists so that with so many Benjamins that it's like you'd be hitting people with cotton balls in terms of like oomph, you know. And then even if you do have a Tasmanian devil disposition, you know, it's just adorable at that stage and there's no threat. Yeah. It's quite scary, KK, quite scary. Speaking of scary.
It's not all bad news, though. There are many ways to reverse what cortisol does to your stressed brain. The most powerful weapons are exercise and meditation.
Raiders! Hammy's Hangout Raiders! Hello, Hammy. Raiders!
From science stream, but we ain't bugging. We over here bubbly. You be chugging what we got. Now the tribes arrive. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Raiders! Welcome on in to Hammy's Hangout. Hammy, how the heck are you doing, friendo? How was the stream? Tell me all the things. Chat, if you do not know Hammy's Hangout, I have met them IRL. They are actually breathtaking IRL and on stream. Occasional IRL streams like Storms. And today, Demonologist. How was Hammy Demonologist today? New game, you said. Did you enjoy it? Did you have fun? It is very spooky to me. When I've seen people play it, it is not something that I will be playing. Even though I play like stuff like Resident Evil. It was good. What was the highlight, Hammy? Please tell me. You died a lot. That doesn't sound like a highlight, sir. That sounds like a less than ideal component of the game. But I'm glad. It sounds like I'm glad you had fun, Hammy. Guys, please go follow Hammy again. Gamer extraordinaire, an occasional IRL streamer, and IRL breathtaking soul. Met him at TwitchCon. For the Raiders coming on with Hammy, my name is Blintz. 1/3 of SciAnts streams. The other 2/3 are my lovely wife Lita and little baby Alona. We are research scientists. We do interactive science streams here on Twitch. We do microscopy, art, sci-fi science, today's science news of the week, deep dives in scientific topics, games, and 3D printing. Tonight we're talking about a paper that was looking at the connection between heart, neuronal firing, and firing in the brain, and how that connects to anxiety. That's the big paper that we're talking about now. Hammy, if there's anything you want to share with us, you know the deal. Mikasa Sukasa, feel free to post here or in the Discord. And for the Raiders coming on in with Hammy, if y'all wouldn't mind hitting that SciAnts logo below to refresh view count, we'd very much appreciate it. We'd like to bring more science to more people, and y'all can help by simply hitting that refresh button right there. Again, Raiders, Hammy, welcome on in, my friend. Thank you for the raid. I'm sharing that I'm going to sleep. Hammy, listen. I hope my favorite place to sleep is a cold room and a warm bed. If that sounds up your alley, I hope you have a cold room and a warm bed to sleep in. If you want the reverse, that's also Gucci. Anything you... Okay, perfect. Then Hammy, may your room be cold, but your bed be warm. May your dreams be filled with not demonologists, but loveologists. Whatever that might be. Sleep well, Hammy. Thank you again for the raid, my friend. I'll take care of the community. And I'll hope to see you real soon, my friend. It's cold at first, but it warms up quick. That's all I need, Hammy. That's all I need. That's perfect. Especially, Hammy, make sure to turn over the pillow so you're on the cool side of the pillow so you can get some good sleep.
In dreams, one is not tethered by earthly limitations. What does that mean? Come.
Sleep well, Big Gamey, and sleep well, Hammy. Y'all have a great evening. Thank you again for the raid, Hammy. See y'all real soon. And Big Gamey, sleep well, too. Big Gamey, good luck tomorrow. I'm sure you're doing all kinds of fancy pants things, as Big Gamey always does. Have a good one, sir. Have a good one. The news coming on in, we're talking about the connection again between heart firing, like neural firing, and the brain, and how that connects to stress and anxiety. These are much better studied in terms of like long time of how long people have had to study this, on top of it seems to be a stronger memory response. That's why they utilize this behavior. And again, if in the study they're looking for stress behaviors, this feature makes sense to utilize. But good question, Optic.
The fear conditioning chamber is a behavioral task widely used in neuroscience to assess associative learning in rodents. Associative learning is the process by which an organism learns to anticipate events by creating an association between two stimuli. The major brain areas shown to be involved include the amygdala, hippocampus, frontal cortex, and cingulate cortex.
So these are, again, the regions of learning and memory they're showing in a human brain, but these regions are maintained in mouse brain as well.
Cingulate cortex. Fear conditioning is a specific form of associative learning that pairs an unpleasant, unconditioned stimuli to a neutral, conditioned stimulus.
I admit I've not been paying fullest attention, but you say conditioned to fear something else. So Zulu, it is called Pavlovian learning. Hold on, Zulu. Hold on. We have the technology to address this. Let's learn about it, Zulu.
You've probably heard of Pavlov's dogs, the phrase that often summarizes Dr. Ivan Pavlov's early 20th century research, in which he demonstrated that we can alter what stimuli elicit a reflexive response in canines. He showed this by sounding a bell just before he presented his group of dogs with meat powder. After many presentations of the bell, followed by tasty meat powder, the dogs eventually began to salivate at just the sound of the bell.
So that's the example, Zulu. That's called Pavlovian conditioning, or associative memory. So if you're training them to associate the stimulus that you're giving them with something else. So with the rats, it's the electric shock that you're getting them to learn about and associate with, let's say, a sound or an image or a smell. And then when you remove the electric shock and you just give them the image, the smell, or the sound, they show the same fear response as if they would have had the electric shock. Does that make sense, Zulu? My dog used to drool when you said the word carrot. KK, I know of a dog by the name of Milo. And based on a very popular music video, it seems like Milo likes carrots. In the popular video Thug's Bunny, starring Thug Shells, Milo seems to like carrots. Andrew, can you confirm this for me, or is that just a byproduct of the video? Carrots was his favorite food. That's lovely, KK. They say it's trying to induce an avoidance behavior that we naturally have gotten some things. For example, it might avoid rotten fruit because it smells bad, so they're trying to kind of replicate it, I guess. Well, not really in this game, Karen, right? Because you never would hear a bell to associate with food, right?
This is true.
Thank you, Andrew. It is fact. We can't say ball in the house because grim. So that's the same idea, Zulu. Same exact idea as how this would work, and same as with the mice. It's just an electric shock instead of playing with the ball. And we have daily associative memories all the time. We also have non-associative memories, where you're remembering something and it's not associated with a smell or a stimulus. You're just remembering it for the sake of it happening.
They salivated even when there was no meat powder present. This phenomenon isn't limited to dogs. Consider the placebo effect, in which a pill with no active substances brings about a response similar to a pill with the substance present. What changes here is our reaction to our ailment, such as perceiving less pain, and not the ailment itself. Or, consider the love humans have for a parent. Some would argue that this love is instinctual, and they might be partially right, but the argument fails to account for the equal amount of love that children adopted later in life hold for their adoptive parents. But the behaviorist argument can account for both accounts of love. A parent, biological or not, is constantly paired with things like food, smiles, toys, affection, games, protection, and entertainment. And a parent's constant association with these wonderful or crucial aspects of a child's life has a similar, albeit more complicated, effect that meat powder had on Pavlov's salivating dogs. In other words, if one's parent is predictive of really good or really important things, then one's parent becomes a really good and important thing too. And there's also romantic advice to be gained from Pavlov's observations. We all need food to survive, right? And someone who can provide such things in a delicious, saliva-producing manner stands to become our human equivalent of a ringing bell. In other words, if you can cook one or more scrumptious meals for a potential love interest, there's a good chance that you'll be viewed more favorably in the future, even if you didn't prepare the delicious food. And who wouldn't want the love of their life drooling over them? But life is not just bell rings and salivation. There's also a dark side to this type of learning called taste aversion. Taste aversion occurs when we ingest some food that eventually makes us sick, and, as a result, we avoid that food, sometimes for the rest of our lives. Taste aversion is so powerful that
That's how I am with beans, by the way. A study where people spent more money on bogus medical treatments felt better even though medically they hadn't changed. KK, it's not just on medical treatments, but food and a bunch of other factors as well, where if you feel like you're putting more in, you feel like you're getting more out, even if there hasn't been anything to be shown on that front, which is quite fascinating, but also frustrating that that's how it works, right?
The effect can be seen even if the illness is experienced hours later, and even if the food itself did not actually make us sick. Such is the case when we have the flu and, by accident, we ingest some food moments prior to vomiting. In this case, we know that the food did not cause the vomiting, but our bodies don't know that, and the next time we encounter that food, we are likely to refuse eating it. Now, imagine the potential consequences of undercooking a meal on a first date. If the food makes your date sick, it is possible for them to associate that bad feeling with not just the food, but with your food in particular. If the episode was traumatizing enough, or if it also happens on a subsequent date, they may come to relate you with the consequences just like Pavlov's dogs related the bell with the meat powder. In other words, the sight of you showing up at the next dinner date might actually make your date nauseous. As the old saying goes, the fastest way to someone's heart is through their stomach, assuming you don't make them sick in the process.
Lol, but quite cool, right? This fact is exactly why I don't eat sushi. Yeah, Dame Karen, same for KK with orange chicken, same for me with beans, which is quite cool, right? Fun fact, I got food poisoning on my second date with one of my exes. May I ask, Andrew, was it a long relationship after that? Or was it pretty short-lived? I wonder if there was some, unconnected, connection to there, right? That you were, pulling back up, subconsciously of, well, there's, a sickness here. Or, if you didn't, maybe, and if you still remembered it, maybe it was an easy justification for being you know what? This isn't working out. I got sick here. Possibly, maybe, potentially, sometimes. I don't know. Possibly. No one caught the Bastion. But, Zulu, I hope that answered your question about the stimuli and their connections back to it.
After the animal associates the two stimuli, it will react to the neutral conditioned stimulus alone in the same way as if it were reacting to the unconditioned stimulus.
Back to the mouse fear conditioning study. It was one of my longer relationships. I just found it funny. Gotcha, Andrew. Avoid Panda Express orange chicken because I legit thought I was going to have to be hospitalized. Wasn't sure I could consume anything but water and Gatorade for 5-6 days. KK, I had the same with a wonton soup when we were in China. So KK, we were at this hotel for a conference, and I got a pork wonton soup. And I started eating the wonton, KK, and I bit into it, and it was a little pink. I will say it was a little pink. But I ate a fair bit of it, and I didn't finish it because it was like, something's off with this. And I was so sick. I was able to go to Lita's talk that evening. She was giving the plenary presentation that first night of the conference. But the second day, I couldn't get up. I was stuck in the hotel. We thought I was going to have to go to the hospital. It turns out you cannot get things like Tums or stomach relaxants in China over the counter. You have to go to a doctor, and we didn't bring any, and I was not about to go to a Chinese hospital. It was a whole thing, KK. I also, so I do not eat wontons anymore, unfortunately. I used to love wontons, but now I'm just nope. I tried KK soon after we came back. We went to a Panera Bread. They had a wonton soup, and I got a side bowl of it. Could not eat it. Could not get over the texture. It's so sad.
Take, for example, a foot shock. Rodents naturally find this unpleasant and will react by freezing. Since rodents are naturally averted to this, the foot shock is considered an unconditioned stimulus. Now, say the foot shock was delivered at the same time as a neutral auditory cue. The animal will learn that the auditory cue is associated with the foot shock.
Have a good birthday celebration, Dame Karen. Give the little niece a hug from us as well. I used to love Panda Express, felt betrayed. Do you still go back, KK, and just not get the orange chicken? That would be okay. Have fun, Dame Karen.
And respond to the auditory cue alone by freezing. The auditory cue is the conditioned stimulus. If the rodent has associated the two stimuli, it will respond to the auditory cue alone by freezing. There are different types of conditioning that can be assessed through the fear conditioning test. They include contextual fear conditioning, cued, delay fear conditioning, trace fear conditioning, backward trace conditioning. Contextual fear conditioning. Contextual fear conditioning occurs when an animal placed in a new environment is presented with an aversive stimulus and then is removed from that environment. If the animal has learned the association between the environment and the aversive stimulus, the animal will freeze upon returning to the same environment. Cued or delay fear conditioning. Cued or delay fear conditioning takes place when the aversive unconditioned stimulus is presented at the end or immediately after the conditioned stimulus instead of at the same time. Trace fear conditioning. In trace fear conditioning, there is a time interval, a trace, between the conditioned stimulus and the aversive unconditioned stimulus. As the trace increases, the association becomes more difficult to learn. This test is more complex and requires additional brain regions in order to establish the response. Backward trace conditioning.
So I'm just giving a bunch of different examples that can be utilized using this container and that, like, how to elicit stress responses as well. Developing an inversion. Exactly, Nola, which is crazy, right? Because there's no connection. Well, it's not true. There are some studies. Physicist Chris, welcome on in. Thank you for the follow. You're part of the colony now, and you're one of us. There are, Nolo, some statistics that say red cars are more likely to get in a wreck. But yeah, even if we disregard red, right, there shouldn't be any reason why if you have a certain color car that you should be getting a wreck. But it's that subconscious fear. And it's a similar metric that we're utilizing for studying these mice. And this is, it's not wild to be able to have that. This is what actually happens within the brain of the mouse using that fight or flight response.
When scared or threatened, mammals can respond in different ways. They can freeze, fight, or run away. Now, scientists have been studying mice to identify the brain regions involved in this split-second decision. They showed the mice a looming overhead threat. The mice responded in the typical ways, either by freezing.
Freezing behavior we just talked about, right, in the previous video.
Seeking shelter.
And the seeking shelter, I realized y'all couldn't see that. But the mice hides under this little shelter outcropping here.
Or aggressively rattling their tails. The scientists monitored the mice's brain activity during the experiment to find...
And that tube right here is kind of what we have in the study we're talking about as well. There's a connection between the lasers shining in on the mouse's brain, how they're being activated, and measuring what neurons are being fired and when they're being fired.
Find the pathways involved in the different responses. They found that mice who had been scared before were more likely to respond aggressively. This reinforcement of aggressive behavior is a survival mechanism, but it could malfunction. In humans, exploring this mechanism could help researchers understand conditions like PTSD and phobias.
And again, in the study that we're talking about tonight, they were looking at the relationship between the heart and that behavioral state. And so the big takeaway, again, it'll bring back our little mouse here. Where's our little mouse? Come on, little mouse. I'm going to show you a picture. Hi, Ringbolt. How you doing? So there's our little mouse being all cutie patootie. Again, so what they did was they're asking if the brain is sensing the internal signals, for example, the rapid racing heart that these animals are having. They use those optogenetic tools, meaning that they can turn on and off neurons in both the brain and the heart using light. And they attach the light to a tiny vest in the mouse, and I'll show you all the tiny vest in just one moment. The light was off, the mouse's heart rate pumped at 600 beats per minute. When the light was on, it was 900, and we do have a video to show that. Here's that example again. Normal heart rate, and then we'll shine the light on, and it very much accelerates. That's one of the strong components that they have there. The rapid fire beat, and this is in real time as well. They're able to monitor and do that. The mice felt their hearts racing. They showed the anxiety-like behavior that we talked about, the various kinds of anxiety and how it's related to in mammals. They then, coupled with electric shock and other fear response metrics as well. They then scanned the brains to find where the processing was happening, and then they actually turned off that region of the brain that was doing that processing, which I think is really cool. Let me show you what the vest looked like. This was the vest here that was monitoring the heart rate. So and there's the light shining, so they can optogenetically activate the heartbeat, which I thought was really cool. See, there again is how the virus was implemented. We're just looking at some of the base figures. Can't remember if some of these were in the supplement or not, but yeah, they were able to identify, like here, what regions of the brain were being activated and which ones they needed to suppress. So they have a bunch of cool traces with firing of the neurons. I think it's in the supplementary information. Let me find the supplementary data. Sections. Go. Not that one. Here again is just another video of looking at that. Thank you, Nelf. I am surprised. I was looking through Nelf. I thought they had in the paper images of how the setup worked. This is a similar one that we just saw in that other YouTube video. I'll post again all these on the Discord as we always do. I thought there had been an image, Nelf, about what this looked like in terms of the actual setup, but it looks like they didn't include that in the primary data. They do have something that we'll zoom in on, though. I think I just missed it earlier. Yes, they have the cartoon set up, which is, we'll have to go with that one, but there it is right there. So there's the little vest that then corresponds, the fabric vest, and they have the anode, the cathode labeled, the thermal adhesive, and then the wavelength of light. So it's all built in together to be able to shine at the heart, activate the high levels of blood pressure and heart rate, and then they can connect and see how it talks to the brain. And so that is, I thought it was a really, really cool science news story. I like the context that they put it in, which was how exactly, if we feel like that accelerated heart rate and how that connects to us being afraid and like our anxiety and fear. And I really, again, like the connection between the two. I had to step away for a minute. No, someone's in an accident. He's okay. Coffee. Please, no sorries for that. Please take care of the kiddos. Coffee, I'm glad that he's okay. Absolutely no problem at all, Coffee Rocks. Please take care of anything you need to do. Coffee, it'll be up on the YouTube later on. Never any pressure to stick around, Coffee Rocks. I just want you to be safe, and I want the family to be safe too. So yeah, that, folks, was the first science news story of the evening, and I think that's where we might actually end up finishing for tonight as well. Tomorrow, Lita's got some horse stuff to do, so I'm going to be hanging out with the little one for most of the day, and then we're going to be on our friend More Amour's stream tomorrow night. He's going to be doing a stream where he's going to be interviewing me about like SciAnts and SciAnts stuff at 6 p.m. Eastern. We'll be over with More Amour, so make sure to drop that follow and tune in for that. If it's collaborate with other SciComs, we do, Physicist Chris. We're planning a collaboration with our friend Rocket Sage, who's a geologist. We also do, we're planning on other collaborations right now with gamers to talk about the science behind certain games. So we do collabs. We also do art collabs. The lovely Stream Scribe is with us on Mondays doing science, or doing letter art in the top corner while we do microscopy. and much more. We're very open to collabs. We're going to be hopefully having a music collab in the not too distant future, and much more. We've actually had a collab with food and drink streamers as well, live on the stream. To be handy for healthcare, a button to slow down the heart. So coffee, it's just, there's a lot of long-reaching potential positive implications for this, but there's a lot of testing to be done still. Oh yeah, we had a collaboration with our friends, the Little Arrow Soap, to talk about how soap works. We're going to be having a collaboration soon with Boyd's Custom Fab about wood. We have 2 microscope physicists, Chris, on the stream. We've got a dissecting scope for 3D samples, and we have a light microscope for sections. And so we're going to be looking at wood samples and talking about the grain and how that works. And so we're very open to collabs here. Yeah, make sure to just join up the Discord. We're doing a collaboration with Moco Made soon. We'll be doing live experiments on their stream. Physicist Chris, any way we can bring more science to more members of the community, that's kind of the mission statement here, and that's what we do here. Welcome the heck in, by the way. So, chat, that was, I believe, hi, Physics in the